Join me in my latest video series as I take you through the steps of how I built this backyard studio. Let's take a look inside. We just finished the principal carpentry on the interior. It's ready for a bit of a clean up, and the clients are going to be doing a bit more painting in here to finish it off. It's a 4 by 6 metre space with 2 doorways, 3 windows, and an overhanging awning on the side. It's a timber frame construction clad in cement sheet with battens covering the seams. It also has a couple of architectural features to give it a slightly Japanese feel, like these extra battens on this wall, the hardwood battening to create the privacy screen. We finished all the primary construction this week, so I'm just going around doing the final check off, like removing the protective coating of these windows. Join me in the next video series and I'll show you all the tips and tricks of how I constructed this backyard studio.
The plan was to create a building that was going to be used as an art studio. My client wanted a comfortable place to carry out her painting in year-round weather conditions. So we incorporated some passive house design features to help keep it warm in winter and cool in summer. By orientating the large double-glazed windows to the north, we can allow the low winter sun to enter the building and warm it naturally. And during the summer months, the extended eave creates a shadow over the windows to help keep it cool inside. The south and west sides of the building are eaveless to help create a mid-century modern architectural look. And the east side of the building has an extended 2.5 metre awning overhang to create an entertainment space. The walls and roof have been constructed with an air cavity batten system and exterior insulation sheeting to help keep it comfortable in all seasons.
I go red when you're sitting there by. I'm like a young child. Silly how time just flies when we play and you hide. You come and go like a monsoon rain. You hide and show like a lightning bolt. You have it all.
Before we start any construction for our studio, we needed to make some extensive preparations on the job site. The studio footprint sits on the top of a grass-covered hill in this backyard, so I needed to create an access driveway to be able to bring in all the tools and materials we'll be needing for the project. My first step was to remove the concrete floor of the old shed that had been demolished. Sometimes the concrete can be left in place and the new concrete foundation poured over the top of it. But in this case, the concrete is of a substandard quality and there's no reinforcement mesh inside it, so it has to be removed. It breaks up easily using a large jackhammer like this. My technique is to place the tip of the jackhammer close to the broken edge and work my way across the slab in small rows.
9 to 5 was my dad's advice. Don't think twice, I want the luxury life. My beauty can lose it, I'll use it. I'll take what I want. Oh yeah.
We start adding the concrete I broke up earlier as a foundation and base for the gravel that we'll be adding on top later. With the lower half of the driveway complete and the next section with its base rock in place, I get another 3.5 metres of gravel delivered. At this time he can back the truck further up the driveway and dump it closer to where it'll be needed for us to finish this part of the project. The remaining concrete rubble from the broken up slab is going to be used to create a small retaining wall to extend the flat area around the edge of our building footprint. I spread out the final load of gravel at the top of the driveway and around our building site in preparation for us building the formwork for our footing foundation. The first key step in our construction phase we'll be building the concrete footing that's going to hold up the studio. It's a 200 by 500 reinforced concrete frame that'll support the entire structure. We'll be pouring our slab for the floor over the top of this in a later phase. To create the form for the concrete footing, we'll be using 190mm wide planking that'll recycle into the timber structure later. We start this process by checking which of our 190 by 45 planks are the straightest, and then start measuring them out for the cutting process. Later on in the project, I'll be constructing a proper saw bench for convenience, but for now we'll make do cutting our formwork on the ground.
I have seen many places where the beauty never ends. Different cities, friendly faces, and perhaps I'm going back.
Here you can see me checking with my set square to make sure that when I connect them together with the screws, it's in a true 90-degree position. I'm using heavy timber screws and pre-drilling my holes, as the formwork will need to come apart later. When the form footing is fully assembled, we slide it into position in reference to the fence line. I'm leaving a 1 metre space between the fence and our structure, which is a standard fire code in our area. The delivery truck is making good use of the track we built as we unload all the framing we'll be needing for the project.
So yesterday we finished laying out our footing for the first concrete pour. This is going to sit underneath the final slab, which creates the floor for the building. We had to align the whole thing in relationship to the existing house and obviously get it level. Instead of using a laser level for this part of the process, I'm using a system I learned off bricklayers in my youth, which is to just use a transparent plastic tube full of water and attach it to some uprights on your structure. And you use the water level to measure down. When you make them both the same measurement, then your formwork's completely flat. So if we take a measurement from the top of our formwork to where the water's settled, in this case it's 1295. And if we go over here, we can take another measurement, and it's 1295, because the level of the water will always stay exactly perfect to gravity.
The next step in building the footing for our foundation is to install the inside perimeter. I'll be using timber dimensions of 90 by 45 instead of the 190 planking we used for the outside of the form. This is to make it easier later on when we have to rip out the form when the concrete's set. I'm cutting all my timbers with a 30-degree angle cut. This is an essential part of how the timber will be able to be pulled apart on the inside perimeter of the form. If I use the normal 90-degree cut, the timbers get wedged inside the concrete. It makes it much harder to pull the formwork out later. I lay out all the cut pieces on the ground for assembly, using small pieces of 190 planking to hold them together. Once they're assembled, I trim them to length and add small pieces of 90 by 45 to help attach the inside corners together. I repeat this process for the rest of the forms and assemble them parallel to the outside perimeter form.
'Cause the thing is, I've got more love here than I can bear. Ooh. Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true. No matter where I go, I'm coming home to you.
With the last form fitting level and parallel to the outside perimeter, we lock it in place on the corners. This completes the formwork for the concrete pour of our footing. With all the form timbers in their final position, I go around the entire perimeter with my rake, making sure the gravel's at the correct height. The 50mm gravel bed that lies under the concrete footing is an essential part of creating a stable platform for the concrete to sit on. Another important part of the preparation of our foundation is to install an electric conduit from underground up through the foundation, so the electrician can connect the electricity up through the wall of our structure later. After I've excavated the hole to what I think is deep enough, I double check with my tape measure to make sure it's a full 400mm deep. Then widen the hole so the bend in our conduit will be able to fit comfortably outside the exterior plane of our wall. I double check the depth one last time, then cut the pieces of my electric conduit and test fit them in the hole. I glue all the conduit parts together, tape up both ends so no dirt will get in, and secure the whole system in place with a wooden block. I'm temporarily removing the bracing blocks we installed to keep the formwork parallel, in preparation for installing the plastic that will be lying underneath the concrete. The plastic concrete underlay comes on a large roll. I purchased a 7-metre piece of it to fit the length of our footing, then folded it into a manageable size, so I'd be able to cut off appropriate size slices for our footings on the job site. Once I've made the appropriate cut, matching the width of our footing, I'm able to unfold the plastic the opposite way I folded it up at the supplier. This is an easy way to manage the large plastic pieces necessary for our damp course installation. When the plastic's in place, I staple it along the edge of the outside of our form to keep it secure during the concrete pouring process. Adding a membrane between the gravel and the bottom of the concrete will stop any groundwater penetrating the foundation and floor for the life of the building. I took extra care to create a tight seal around the electric conduit that penetrates the membrane.
We're going to be pouring the concrete for our footing today. We just have to throw our steel in. I'm going to cut a couple of extra blocks like this, help keep our formwork parallel as we fill it out with concrete. We'll be mixing this pile of pre-mixed gravel and sand with our Portland cement.
One of the key elements for our foundation is the steel reinforcement that sits inside the concrete and gives it tensile strength. I use purpose-designed plastic shoes to lay the mesh out inside our forms. The plastic shoes help keep the reinforcement mesh at the correct depth and keep it stable throughout the concrete pouring process. Here we're using trench mesh, which comes in a configuration designed for a foundation like this. After our reinforcement steel's in the right position, we click in the plastic shoes about every metre to give it a stable platform for the concrete pour. We work our way around the entire perimeter of the foundation, installing the trench mesh over the plastic shoes and taking care not to puncture our damp course underlay.
Hey darling, can I tell you what's been on my mind? Sick and tired of the 9 to 5 in the city life. Hey darling, we could get out of town, see the beautiful world around, wanna see it now.
The final step before we pour concrete is to cut and install wood braces that will help hold the timber formwork completely parallel as we pour the concrete in it. I'm installing them every 2 metres around the entire perimeter of our foundation. My plan is to pour the entire concrete footing in one day. By starting the pour at the far end of the foundation and working around both sides at once, we can get all the concrete into our formwork without any of the concrete setting up before we're complete. This is an essential part of creating a strong foundation, and in the concrete business it's called creating a wet pour. With only 2 of us doing this, I've delegated Chris to focus on mixing the concrete and dumping it, while I focus on pushing the concrete into the formwork and in and around the reinforcement steel. The wet concrete dries and stiffens quite quickly, so it needs to be constantly agitated with a shovel and trowel to ensure we don't end up with any air bubbles or voids that are trapped in the concrete and weaken our structure when the concrete sets.
You said, let me tell you everything I've seen, the friends I've made, and then you tell me how you've been.
Here you can see Chris mixing the ingredients of our concrete. For this pour, I'm using 6 parts of our sand gravel mix to 1 part Portland cement. The Portland cement is what binds all the sand and gravel together to create the concrete. Part of getting an effective concrete mix with a small mixer like this is to give the ingredients time to mix together. You'll notice how Chris pauses in between adding some of the ingredients to let the concrete blend. When the sand, gravel and Portland cement are thoroughly mixed together, we dump it out into the wheelbarrow. He brings it over and we continue the process of filling our formwork.
Underwater, so far out at sea.
Another technique for removing air from the concrete is tapping the side of the forms with a hammer. Air gets trapped on the edges of the concrete up against the forms and the plastic. So by constantly, periodically tapping the form, it removes all the air bubbles and ensures a really strong foundation. Here I'm moving the timbers we've been using as a system to stop the concrete spilling over the edges of our formwork as we dump it in from the wheelbarrow. As a segment of our formwork becomes filled with concrete, I move the timbers to a new position. This is an indicator for Chris where to dump the next load of concrete. As each segment of our formwork is filled, I start the final troweling process to create a smooth surface on the top of our foundation.
A bit naive and so eager to please. You know I played for love, but it got me on my knees.
As part of the engineering design for our foundation, we're adding 2 pieces of 14mm rebar on top of the trench mesh. By having a double layer of reinforcement steel inside the concrete, it adds a significant amount of strength and will avoid any cracking or subsidence over the life of the foundation. I place the 14mm rebar lengths on temporary wooden blocks. As we fill out the formwork with concrete, we'll be removing these blocks as we go, which will leave the steel suspended at the correct height inside our foundation.
I'm on my way. Yes, I'm on my way.
I removed the drawbridge section of our ramp we've been using to ferry the concrete over our foundation all day, so Chris can dump concrete for this final section of formwork. After adding enough concrete to fill it over the top of the trench mesh, we add our final pieces of 14mm rebar for the extra reinforcement. We then continue to fill out the formwork until it reaches the top, and then start the troweling process to finish it off. I work my way around the entire perimeter of the foundation, making sure the concrete's sitting flush with the top of our formwork. This completes the concrete pour of our footing. We let it set up overnight before continuing the next step. The next morning we start deconstructing the formwork in preparation for the slab that we'll be pouring later. We start this process by unscrewing the bracing blocks we added to keep our formwork parallel whilst we poured the concrete. We're collecting all the screws in a yellow tub as I try and recycle as many materials as possible in my projects. I do a quick inspection to check the quality of the concrete pour before removing the forms from the inside of our footing. The outside forms are going to remain in place until we complete the concrete for the floor slab. Because the inside forms are made out of multiple bits of timber, they deconstruct and come away easily. Truck makes good use of the gravel driveway we constructed to deliver our next batch of concrete mix for our slab we'll be pouring tomorrow.
Bad news is we're getting rained off today, but the good news is it didn't rain like this yesterday when we poured this footing. So everything's looking good so far.
The rain passed over a few hours later, so I returned to removing the formwork. Here you can see how having a 30-degree cut where the timbers join helps them come apart and stops them jamming. I stack all the materials off to the side so I can reuse them later in the timber framing.
Cutting grass and chopping wood can be romantic. sipping coffee under the apple tree.
I tape the damp course to the top of our footing to keep the damp course out of the way of the gravel we'll be adding later.
When the wind blows and the windows are closing, you let the world know that what has been.
I'm installing a drainage system that'll be sitting inside the gravel that's under the floor slab of our structure. This is to ensure that any water that infiltrates our footing has a way of draining and keeping the gravel dry, which will avoid any kind of rising damp in the future. I get a measurement for the 90mm slotted PVC pipe we'll be using for constructing this drain and cut it on my chop saw. The plan is to create a square loop around the inside of our footing, connected to the PVC pipe that I put in place before we poured our concrete. The pipes need to be placed on a slight downhill angle to keep the water draining out of the system. I dry fit all the pieces of pipe in place to check for fit and then return to glue them together.
You master how to simplify. You turn rain into a blue sky. Oh, when the wind blows and the windows are closing.
After a light sanding, I apply the glue to the connecting surfaces and push the parts together. It's important to have the pipes set at all the right angles in the dry fit process. The glue sets up really quickly and it's hard to bend the pipe once it's set in place.
Cutting grass and chopping wood can be romantic. Sipping coffee under the apple tree.
With the drainage system complete and in place, I set up the ramp that we used when we did the concreting. Part of my building process often involves the construction of temporary structures to aid me with my materials and tools. I often have to construct scaffolding, temporary staircases, and in this case a ramp system so we can efficiently and effectively move all the gravel we need to into this foundation. I start by adding gravel on and around the pipe to help hold it in position. I don't want to move the pipe out of alignment whilst we fill this void with gravel. We're using a 30mm aggregate gravel, which will be effective for the drainage part of the system and also compact quickly and easily for the slab that we'll be pouring later. After adding most of the gravel in and around the pipe, I do one last check with my spirit level to make sure I haven't moved the drainage system out of alignment during the process. The next day, Chris gives me a hand with filling the bulk of the gravel inside our foundation.
Oh, I will open up my eyes so I can see the light. Oh, and I'll try to spread my wings so I can fly.
As the gravel gets close to the top of our drainage pipe, I construct a screed so we can level out the gravel exactly 75mm below our footing. This is to allow space for the waffle board insulation we'll be putting in later. I've attached a 75mm thick piece of timber under a dead straight 2x4. This gives me an accurate indication of what level to rake the gravel out to.
Oh, I will open up my eyes so I can see the light. Oh, and I'll try to spread my wings so I can fly.
Due to the fact we'll be constructing this studio over the winter months, I need to build a temporary shelter so we can carry out our construction when it's raining. We're building a simple shed with timber framed walls and a corrugated iron roof. It'll only partially cover our building platform, but have tarpaulins we can extend out to create shelter from the rain, especially for the next part of our process, which will be pouring the concrete floor slab. Our rain shelter is going to be set on planks so we can move it along the building platform as needed. The planks we'll be installing happen to be lying right where I want to put a drainage system to help keep the backyard from flooding. So we're going to pause our shed construction and install the drainage system. I'm using rigid slotted PVC ag pipe and aligning it along the entire length of the footing to help redirect any water that builds up in the backyard. I cut it to size, glue the parts together, and bury it in preparation for the plank we'll be installing for our temporary rain shelter.
Everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it.
With the drainage system buried, we return to constructing our rain shelter, starting with the planking that'll be the foundation for the walls and allow us to move the rain shelter as needed later in the process.
Now everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it.
As part of the preparation for the floor slab, I'm rolling out plastic damp course. This is one of a couple of materials I'm using to create a membrane so the groundwater can't penetrate our concrete floor. I use this heavier damp course material around the entire perimeter of our foundation and then tape the lighter building plastic to it later. As part of the preparation for building the formwork for our floor slab, I want to set up a decent cutting bench so I can make highly accurate cuts in my timber throughout this project. I'm using some pallets as a base, set on top of the retaining wall we created with the excess concrete debris.
Can I go and sleep, buried in my chair? The only thing that's left.
We're using 45mm by 90mm dimension timber for the framing of our concrete floor slab. In imperial measurements, that's a 2x4. After cutting it to the correct length, I'm pre-drilling screw holes so we can attach it to the top of the footing forms. After attaching it to the corners with heavy timber screws, we double check that it's lying completely flat and straight. I then repeat this process for the other 3 pieces around the entire perimeter of the footing. To ensure the formwork ends up completely square and parallel, I'm cutting a template. When I'm satisfied it's cut to the right length by checking it in the corner, we move it to the center of our forms to establish a perfectly parallel layout of the timbers. I fix it in place with heavy timber screws every meter to ensure that it doesn't move out of alignment during the concrete pouring process.
I'm gonna stay right here. Stay until it disappears.
Yesterday we set the form for the top slab and squared it off. Today we have to do a little double check to make sure it's perfectly level in each corner, in each midpoint. Maybe add a packer or 2 just to get it as perfect as we can get it. We're going to be pouring this slab in 3 parts as part of how we need to manage it to get a nice finish on the top. It'll also mean there'll be expansion joints in the slab so we won't get any cracking down the road. One of the main reasons I built this temporary shelter was for this concrete, because we're doing it in winter and it rains all the time around here. And then throughout the construction of all the framing and walls, I can move this shed back and forth on the tracks we established on the side. So the idea was to be able to keep my job site sheltered throughout all the rainy season. We're getting some waffle boards delivered this morning, which will be a 75mm polystyrene underlay. This adds a lot of thermal insulation, stops your slab feeling cold, and when you heat this space, the ground won't be able to suck all the heat out. So by keeping the whole foundation dry and watertight, it really helps the insulation, stops you losing all this heat through the ground. So if all goes well, by the end of the day, we'll have 1/3 of this slab poured out and polished off.
To double check the level of our formwork, I'm using the same method I used on the footings. I have a transparent piece of plastic hose filled with water, and by setting the level in one corner, I can transfer the level around the entire perimeter of the foundation. As I find areas of the formwork that need adjustment, I back out the heavy timber screws and add packers underneath to get it into level, and then reset the screw to keep it stable for the concrete pour. With the formwork completely level, we continue our preparation by adding the waffle boards I mentioned earlier. Once we've cut and fit all the waffle boards in place, we add the plastic membrane, which will be the damp course for our system that stops moisture coming up from the ground into our floor. The final step in our preparation for concreting is adding the reinforcement steel. We cut it to size using an angle grinder with a metal blade. Add the plastic shoes that help keep the concrete at the right height inside the slab, and then fit it in place in preparation of our concrete pour. One of the important parts of a concrete pour is to get all the concrete into the designated form in one pour in one day. To help achieve this, I've got two guys helping me on this pour. Chris is focusing on mixing the concrete and delivering it in the wheelbarrow, and Bazza is agitating the concrete through the mesh into the form. I'm using my regular concrete formula, which is 6 parts gravel sand premix to 1 part Portland cement. After Chris mixes a batch of concrete, he dumps it in the barrow and transports it to Bazza to push it into the form. We keep repeating this process until the concrete gets close to the top of our form.
I'm gonna stay right here. Stay until it disappears.
When the concrete reaches the top of our formwork, we start the next process of screeding the slab flat. While Baz is moving the concrete float back and forth to smooth out the surface of the slab, I'm adding extra concrete to any low points I can see. We've started this screeding process on the left-hand side of our slab, and we're going to work our way towards the right. When all the concrete's been filled and flattened, then our slab will be done.
If you have love, you wanna give me some, and I would wait for someone else to come. Oh, it's sad, but it feels right.
With the concrete floor slab basically finished, I take one final pass around the edges to make sure that it's extra flat and smooth, as this is where the timber wall frames will be sitting, and I want to make sure they're completely flat and level. Before we finish for the day, we're going to string up an extra tarp to our temporary shed. It's already started raining lightly, and it's important to protect the concrete from the overnight rain.
Yesterday we successfully poured the first section of our slab that'll be the finished floor in the studio. Luckily we built this shelter because it rained on me 3 or 4 times yesterday. I was able to keep the slab drier.
As part of the preparation for the next slab we're going to pour, I'm making sure the formwork we're using as a divider is set completely level. I'm using packers to make an adjustment so it matches the rest of the formwork. I then secure it in place with heavy timber screws. I'm now ready to install the waffle boards that'll be adding a layer of insulation under our concrete floor slab. I adjust the gravel as necessary to align the waffle boards level to our footings. These dense polystyrene panels are purpose designed to lay under concrete and are part of the passive house elements we're adding to our structure to keep it warm. The waffle boards offer a thermal break between the floor slab and the ground, which will reduce the amount of energy needed to heat the structure and keep it warm through winter.
Tired snowflakes are coming down, collapse into water when they hit the ground.
When all the waffle boards are fit and level to our footing, I add the plastic underlay. This will stop the groundwater rising up into our floor slab.
Quiet voices in the night, time is running out of sight.
We're now ready to pour the second of the 3 slabs we'll be pouring to create the concrete floor. One of the reasons I'm pouring the concrete in segments instead of one complete pour was to save money. I discussed it with my client, and because she's using the studio for painting, she didn't mind having a slightly rough concrete floor. So by pouring it in multiple segments with a smaller crew, we're able to get the concrete floor put in the ground for about half the price.
Daydreamer, kidnap me, take me back all the way back.
second slab set up over the weekend before preparing for the third and final slab of our floor. I remove the form timber that divides the slabs and then double check that our gravel's at the right height for the waffle boards we'll be adding. I purposefully left extra lengths of membrane under the first two slabs so we could join them together under this third slab. By adding an extra piece of membrane to this join, I can create a wider overlap and ensure a waterproof connection in the damp course. I then secure all the seams with gaffer tape before adding our waffle boards on top. They delivered the concrete materials we'll be needing for this third and final slab. I then started preparing the reinforcement steel we'll be adding.
So offshore, playful and free, without a care in the world. I was one rich little girl, daydreamer, kidnapped me.
In preparation for the third and final slab, I need to move the rain shelter into a better position.
Every step, every breath, for you, my head's up over the clouds. For you, if there's a valley, I'd build a bridge so that you could get by.
It takes a little bit of effort, but I can move the whole shed cover by myself. Now it's sitting over the pub. We're going to pour the concrete in tomorrow because we've got rain predicted. We're going to set some ramps up so we're all ready to pour our concrete tomorrow.
Imagine it, it's my new best friend. Raise all I see. I got a PhD in love. My heart covers every degree, but there's no guarantee in love. No, we just have to wait and see.
After completing our slab pour, we wrapped up our temporary shelter with tarpaulins. As I'm expecting light rain overnight, I want to protect the concrete.
Over and over, injustice to injury. This is a part of it all.
Yesterday we poured the last piece of our concrete slab, which is also going to be the floor of our structure. Let's go take a look. I'll pull some of these covers off so I can get a closer look at the concrete, but it's looking really good. The footing and foundation and floor for this is now complete.
The next thing I want to do is raise the tarp so I can get a better look at how our concrete turned out. It's successfully cured overnight, but I can see there's a slight bit of damage from a leak in our temporary roof. There was a lot of heavy rain last night, and it's made a small hole in the surface of our concrete. You can see here how much rain there was by the amount of water in the wheelbarrow. For concrete to reach its proper strength, it needs to be kept wet whilst it's curing. So I'm securing some plastic covers for our slab and stapling them to our formwork so the wind doesn't blow them off. Then by wetting the concrete down with my hose, the plastic will keep the concrete wet for a couple of days so I can harden up properly. I then pull down the remaining tarps in preparation for removing some of the formwork.
Yesterday there was sun and there was rain, beauty in the Monday.
Here I'm clearing the head of the screw of concrete before I remove it.
And now there's something in the air and a sparkly shimmer on our skin.
After I remove the timber forms, I stack them off to the side because we'll be recycling these into the structure later. I need to do a little digging before I remove the formwork for the footing and get to see how the concrete turned out. I can see I got a nice solid pour on the footing and the slab. I need to cut this excess damp course off in preparation for the waterproofing we'll be doing later. I'm using an angle grinder with a diamond bit to cut this excess damp course completely flush to the slab. I don't want any excess plastic catching water and pushing it into the concrete floor.
Hand in hand, building castles out of sand.
I then work my way around the rest of the slab, cutting any excess damp course off the concrete.
Head up high, now we climb.
As I remove the last few pieces of formwork, I can see the rain is setting in, so it's time for me to make some adjustments to the temporary shelter and the tarps so I can continue working in this weather.
Peel off the layer and breathe. Lift up your head and lead. Count the stars up before you leave.
After trimming the excess damp course around the entire foundation, I tidy up the top edge of the concrete floor slab with my grinder, so when I attach the wall plates it's completely flat, level and plumb.
As part of the mitigation for working here during the rainy season in winter, I'm going to make a few adjustments to my tarp arrangement. Got this piece of timber set up on the old shed structure yesterday, which is working really well. The tarp I was using was old and had lots of holes in it, so I'm going to replace it with 2 tarps. So have a split in the middle that'll help stop water building up inside it.
It's worth going to the extra trouble to create a secure shelter from the rain, as I'll be constructing this studio for many months through the winter weather. By fixing the timber battens with heavy timber screws over the tarpaulins, I'm hoping it'll hold up against the wind for the life of our project. After the tarps are secured to the shed roof, I'll work on a system for securing the bottom edge of our tarpaulins. I'm using a piece of PVC pipe as a boom and attaching the edge of the tarp with roofing screws and large plastic washers to help stop the tarp ripping off in the wind. Once all the parts are assembled, I set it up in preparation for me waterproofing the edge of the concrete floor and footing. I'm using a waterproofing product that's called the Celastic Cement Additive. It gets mixed together with 5 parts Portland cement and water to 1 part sealant to create a slurry that you paint directly onto the concrete or cement. I'll be applying a couple of coats of this around the edge of our foundation and concrete floor. This is to stop any moisture penetrating the side of our concrete. I'm installing a drainage system down the side of our structure next to the fence. I'm using perforated ag pipe to redirect the water down the hill below the studio. The backyard we're building in slopes gradually away from the main house towards where we're building the studio. The studio foundation is acting a little like a dam, so we have to create a passage for the water to come around it to avoid any flooding in the future.
Stay close when it rains. Let me keep parts of you. Hand in hand is how we sleep every night.
As part of preparing for the carpentry phase of our project, I'm adding a roof to my saw bench to help keep me and my saw dry throughout the rainy season. I'm constructing it with some scrap timber and the tin that was left over from the old shed that we're replacing.
We will dance away the gloomy days right here. We are silver line, one of a kind, you and me.
The floor slab edge and footing need a second coat of our waterproofer, so I thought I'd take you through the process of how I make up the slurry. After adding the Celastic waterproofer and water, I start adding the Portland cement. I'm using a small plastic container to keep the correct ratio of 5:1, then spooning it into a piece of fly screen mesh to help take out any lumps that are in the general purpose cement. After mixing all the ingredients together and making sure there's no lumps, I apply the slurry to the side of our concrete foundation like a paint using a brush.
Give me tears so I can cry. And give me life so I don't die.
To help save money and resources, I often reuse the formwork timbers into the framing of the structure. Here I'm sanding the 90 by 45 timbers I used for the concrete floor forms. Before I start cutting the framing material for our walls, I want to check the calibration of my saw setup. The timber needs to sit completely flat and level along the saw bench we constructed and line up square with the bottom plate of our saw. Once I've checked the timber is aligning properly with our bench, I do a test cut to make sure we're getting a true 90-degree cut in both dimensions. I want to make sure the tape measure we attached to the saw bench is reading accurately. It can save a lot of time having a dedicated tape measure attached to the bench, and I can see here that it's reading true. The last thing I check is the accuracy of how the saw cuts. I use my set square to check that the saw is cutting 90 degrees vertically and horizontally. I'm now confident that the framing we're about to cut will come out true and square. Part of building efficiently is working off an accurate drawing to scale. It's essential for estimating the materials I'll need on site and helps me create a cut list for the material I'll need to assemble for our structure. By referencing the drawing of the first wall we're going to frame, I can see that we need 9 studs at 2230. I transfer this information to my cut list and then start selecting the material we'll be using.
Mud on your boots tell the story of where you've been. Travel, beat up, warning with settled soul. Trust your gut, you have earned at least that.
When you're cutting 9 pieces of timber exactly the same length, it's more efficient and accurate to set up a saw stop on the bench. That way they all come out exactly the same. With all the studs cut for the first wall, my next step is to measure and cut out the bottom plates for our 4 walls. The bottom plate is the piece of timber that connects the framed wall to the concrete slab. I'm laying out the bottom plates on the concrete slab in position. I have to calculate a cutout for where our electric conduit enters through the plate. I mark it out with my pencil and then cut it out with my saw and chisel. After the notch is cut and cleaned up to the appropriate depth, we return all the plates in position so we can do some calculations to determine where we'll be cutting the plates and setting them on the concrete. When I'm satisfied everything's positioned correctly, I mark out all the inside corner points on the concrete and the timber for accurate assembly later on.
Out where time seems to fade, learn to master your mind.
When all the bottom plates are cut to size, I place them around the edge of the concrete slab under plastic. I need to keep the edge of the slab dry for an anti-termite membrane product I'll be installing later before we put any of the walls up.
9 to 5 was my dad's advice. Don't think twice, I want the luxury life. My beauty can lose it, I'll use it. I'll take what I want. Oh yeah. A whole lot of ticking, but not enough time.
After receiving all the sheeting material we'll be needing for our studio, I return to framing our first wall. It's a standard building practice to assemble the wall flat on the floor of your structure, securing all the studs into the top and bottom plates, and raise the wall in one piece later. I start this process by securing the top and bottom plates to the corner studs of the wall. Often in wall framing, nails are used to attach the studs together, but in our case I'm using heavy timber screws as we have damaging cyclonic winds in our area and I want to add as much strength to the walls as possible. After securing the 4 corners of the wall, I add the 9 studs we cut previously. I'm using a standard stud layout of 600mm on center. To complete the frame, I'm adding a connection point on the end for the other wall to connect into it when we assemble it. This is also known as a California joint. assembling the frames, I sometimes use a packer to keep the studs flush to what'll be the outside of the wall. I'm using 14 gauge 100mm heavy timber screws and always pre-drill my holes. This helps keep control of where the screw's going and avoids splitting in the timber. I always double check which way the timber is bent by running my eye along it. In this case, I want the crown of the timber facing the outside of the wall.
9 to 5 was my dad's advice. Don't think twice, I want the luxury life. My beauty can lose it, I'll use it. I'll take what I want. Oh yeah. A whole lot of tickets, but not enough time. A whole lot of work for a trophy wife like me.
I periodically check the connection points with my set square to make sure everything's being assembled at 90 degrees. And sometimes I use a clamp to help tighten everything up to a 90-degree angle, as none of the timbers are perfectly straight.
Spending Sunday at the gym, trying to fit in. Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of tickets, not enough time, not enough time.
We're hoping to get the termite guy here today to put a special band around the entire slab. It helps mitigate against termites getting up into the frame.
They're installing a specialised anti-termite membrane around the base of our footing and slab. The concrete slab needed to be dry for the glue they're using to attach the membrane. So with all the wet weather we've been having, it's delayed the installation of the product. Once this membrane's in place, I can raise the first wall of our structure.
'Cause the thing is, I've got more love here than I can bear. Ooh. Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true. No matter where I go, I'm coming home to you. Been walking down the street so many times, my feet know every brick and stone. Could wear a blindfold. No matter what I do, I'm coming home to you. And I don't know why, don't know why, don't know why I'm always feeling homesick. Oh.
While I'm waiting for the termite membrane glue to set up, I'm preparing studs for the walls we'll be assembling later. As I did earlier when cutting the previous studs, I have a scrap piece of timber attached to the saw bench to make it easy to cut all the studs exactly at the same length. I stack all the cut studs together, aligning both ends as a way of double checking there's been no mistakes in the cutting process and that they were all exactly the same length. The final preparation for the studs is to seal the end grain with timber sealant. I'm using a lanolin-based timber seal on all our framing for the studio as a way of minimising the amount of moisture that'll end up in our structure through the rainy season. By painting the sealant on when the studs are in a stack like this is a quick and efficient way of completing the process. To make things easier for myself, the first wall I've framed is a smaller wall that doesn't have any doors and windows. The first wall has to be held in place by timber braces, so it makes it a lot easier if you pick a smaller wall to erect first. When we erect the other walls, this wall will help hold them in place.
I have seen many places where the beauty never ends.
One of the ongoing preparations for all our unpainted timber material is to coat them with a waterproof wood sealer. This will help minimise the amount of moisture that can get into the sheeting material and framing, which will help avoid mould and mildew growing in our structure before we have it completely covered. We're using a spray paint system for speed and efficiency, and Chris is making sure he's putting an extra thick coat on the edges of our OSB sheeting, as this is a really vulnerable area for absorbing moisture.
Back up the drive a bit, could you see what this is? This is a part of it all.
for the second wall, I start the process by marking out the top and bottom plates. The two plates are clamped together and set in their final position as they'll be when they connect to the wall we've already erected. I need to set the frames about 50mm inside the edge of our concrete slab to allow for the rain screen. I'm using a selection of packers that represent the sheeting, insulation and battens we'll be using to create the rain screen. This will help me make an accurate setback of our walls from the edge of our concrete slab. With my tape measure clamped in place so it won't move out of alignment, I can start the process of marking the top and bottom plates both at once. I'm using a standard stud layout of 600mm on centre. I use my set square to mark the positions of the studs on the top and the sides of the plates. With all the wall studs marked out on the bottom plate, I can drill the holes for the anchor bolts that'll be securing the wall to the concrete. I'm drilling 12mm holes, about 75mm from the stud line. The holes we're preparing are part of a ChemSet system for epoxying steel bolts into the concrete to hold the wall frames up. I then start laying out all the pieces for the wall on the concrete slab. After laying the top and bottom plates parallel to each other, I go through the studs we prepared earlier, picking out the straightest studs for each end of the wall and putting the others aside to fill out the middle of the wall. I then align all the wall studs to the marks we drew on the bottom plates earlier and prepare for screwing the whole wall together. I start by fixing the corners together with 200mm 14 gauge heavy timber screws.
This is a part of it all. Ask around, make peace with what is there.
As I did when I assembled the previous wall, I used packers to keep the studs flush to the outside plane of the wall.
Who told you that it was too late? When was it that you started leaning that way? 4 tires cut into the clay. It dries up and now there's just one road to take. It's growing up over with green.
The way I'm attaching the studs to this second wall is slightly different from the first. I'm fixing the studs from the inside so I can remove them later, due to the fact that our windows are running late and I'm not sure of their exact size. To save money on our build, we're going to be using factory second windows, and I won't be certain of their exact size until they arrive on site. So by making the studs removable, we can custom fit them later.
Over injustice to injury, this is a part of it all. Could you hike back to it, fight with it, sit with it? This is a part of it all. Ask around, be aware, make peace with what is there.
With the first two walls connected together in place, I start the process of gluing them to the concrete with liquid nails. After cleaning the concrete slab thoroughly with my blower, I prepare a tube of glue and start injecting it between the bottom of the plate and the concrete. I have temporary plywood packers under the wall plates to create a gap for me to inject the glue into. After applying the glue to the entire length of both walls, I start the process of removing the plywood packers using a crowbar to lever the wall up as I remove them. The wall then settles on top of the glue, connecting it to the concrete. I finish the process by working my way around both walls using a small sledgehammer to make sure there's no air trapped in the glue. I do one final check by eye to make sure both walls are plumb and sitting on a flat plane. With both walls looking in perfect alignment, I allow the glue to set up before moving on to the next step. One of our passive house design features for our studio is the overhanging eave on the north wall. This is to stop the summer sun from coming in the large windows. To establish the exact length the roof is going to overhang on the north wall, my client wanted me to set up a temporary roof rafter so she could visualize it. Once we'd established a satisfactory overhang and height for the roof, I was able to double check my measurements for the third wall we're about to construct. We're constructing this third wall the same way we did the previous two, by laying out the top and bottom plates and marking them for the stud connections. In this case, Chris is transferring the marks from the bottom plate to the top plate. Both plates are clamped together to ensure accuracy and to stop anything being bumped out of alignment. I cut the first stud for the wall, and in this case I want to double check it against the temporary rafter we set up to make sure the height aligns correctly. With this first stud cut to the right length, I use it as a template and screw down a scrap piece of timber on the saw bench so I can cut all the other studs exactly at the same length.
Hey, darling, we could get out of town. See the beautiful world around, wanna see it now.
The third wall is about 250 mil higher than the other walls, so we have to move our temporary rain shelter out of the way to raise it. We constructed the shelter on timber tracks, so by using small pieces of pipe, we can roll it into its new position so it's out of the way for us raising the third wall. After making a few adjustments to the temporary shelter to make sure it's out of the way of our wall, we raise it in place. I then lock it into position with some 2x4s as braces. With the liquid nails glue set solid under the first two walls, I'm going to start the process of chem setting the bolts through the bottom plates into the concrete foundation. I'm using an impact hammer drill to drill 12mm holes into the concrete through the holes we prepared earlier in the bottom plate. I need the holes to be 250mm deep so the all thread can penetrate through the timber frame, through the 100mm slab and into the concrete footing. I clean out all the holes with my blower. It's critical to remove all the dust from the hole, or the epoxy we add later won't be able to adhere to the concrete properly.
You said, let me tell you everything I've seen, friends I've made, and then you tell me how you've been. Look a little closer, it's been quite some time. You gotta let me know if I'm out of line. But there's some words that I just want to say, to put it all straight before this night turns into day, and then I'm on my way. Yes, I'm on my way.
I use the 12mm all thread as a depth gauge to see how deep my holes are. I check the depth of the other holes I drilled using a tape measure to check that I got at least 200mm deep. To cut the all thread into the lengths I need, I'm using my drill to help spin the nuts on so I can use them as indicators on where to cut them with the grinder. It can also be difficult to get a nut on a cut piece of all thread, so it's easier if the nuts are already in place. I use my drill to keep the all thread spinning whilst I drag the nuts across and leave them in equal intervals. I then double check with my tape measure that they're set at the right distance. When I'm satisfied all the nuts are in the right place, I cut them into pieces with my grinder. I then set up the specialised caulking gun for the two-part epoxy. This particular brand's called ChemSet, and it mixes the two parts of epoxy as you inject it out of the tube. You have to work quickly when using this kind of epoxy because it goes off really fast and will block the tube once it starts to set. That's one of the reasons I go to so much trouble to stage and prepare everything so I can move along the whole wall quickly.
To put it all straight before this night turns into day, and then I'm on my way. Yes, I'm on my way. A bit naive and so eager to please. You know I played for love, but it got me on my knees.
While I that the epoxy's set up for the first two walls, I start the preparations for fixing the third wall to the concrete slab. I'm drilling 12mm holes for the angle brackets that'll be in each corner of our studio. The corner brackets are part of the engineering system that'll stop uplift from high winds we get in our area. Placing a bolt in the first hole we drilled helps keep the bracket aligned for the rest of the holes we're drilling.
Turn rain into a blue sky. Oh, when the wind blows and the windows are closing.
I then drill 12mm holes to prepare the bottom plate for the fourth wall that will be assembling vertically in place later. To prepare the third wall for gluing to the concrete, I'm placing small pieces of 6mm plywood underneath the bottom plate to create a gap for me to inject the glue into. Once I've finished placing the plywood packers about every half metre along the entire wall, I remove the 2x4 blocks we had in place whilst we were drilling the 12mm holes. I then inject the liquid nails with my caulking gun inside the 6mm gap we've created with the packers. I'm creating a continuous glue bead in between the bottom plate and the concrete. Adding glue like this between the wood and the concrete creates a gasket that achieves an airtight seal between the two different materials. This helps avoid micro drafts in the final structure and is part of the insulation system of the building. Once the glue bead is complete, I use my crowbar to lever the bottom plate off the ground whilst we remove the plywood packers. The wall then settles on top of the glue. I finish off the process by using my small sledgehammer and tap it all the way along the bottom plate to remove any air bubbles that are caught inside the glue. Before the glue sets solid, I want to check the walls sitting completely straight along our concrete floor. So I set up a string line with some 10mm packers. By placing a 10mm packer under the string at either end of the wall and then another packer in the middle of the wall, that establishes that our wall is completely straight. I do one last double check by eye before moving on to gluing the final bottom plate down of the fourth wall. Like I mentioned earlier, we're constructing the fourth wall slightly differently from the other three. Instead of building it flat on the concrete and raising it, I'll be building it vertically in place. Once I've applied a generous glue bead all the way along the concrete, I carefully place the bottom plate aligned between the two standing walls. I then leave a heavy piece of timber on it to help it set up overnight.
You master how to simplify. You turn rain into a blue sky. Oh, when the wind blows and the windows are closing, you let the world know what has been has been. There's no use in looking back, going back, wishing back.
After trimming the all thread flush to the bolts that we epoxied in yesterday, I start drilling the bolt holes for the third wall. Some of the bolt holes can't be drilled 250mm deep because they're running into rebar inside the concrete. When this happens, I just leave the hole shallow. In this case, the hole next to it is going to the full depth, so it's not going to matter. After drilling all the holes along the wall, I start the process of cleaning out the holes, and this time I'm using a system where I put a piece of wire inside my drill and it helps scratch clean the hole from the inside out. I then use my blower with a piece of tube attached to blow out all the dust particles. I double check the holes are clean by placing a bolt inside and removing it and taking a look at how clean the bolt comes out. Before I bolt down the third and fourth wall plates, I want to square up the three walls we have standing by adding cross braces to make sure they're completely square and plumb. as we bolt the other parts of the wall down. Once the cross braces are screwed in place, I remove some of the temporary braces and do one last double check with my level to make sure the walls are completely vertical and plumb. I successfully drilled 250mm deep holes for most of our bolt connections. This is important because it's the only way the slab is connected to the footing. Because the slab is poured over a waterproof damp course, there's nothing physically connecting it to the concrete footing underneath except gravity. So by having the bolt penetrate the slab and go deep into the footing, it connects the two pieces of concrete securely. This is part of the engineering to avoid uplift due to heavy winds. Once all the epoxy is set solid and our bolts connecting our bottom plates, we'll be ready to start constructing the fourth and final wall.
Late last night I finished the principal framing for the walls. Let's go take a look at some of the details. The other three walls we built flat on the concrete and raised them. This last wall, it was just easier to build it in place. So last night I finished putting in the last of these studs. The reason we've got a big gap here is because we've got some doors and windows coming. We're not exactly sure where the door's going to go. So I've just left this open. We know the door's going to be somewhere in this area, so I can keep my construction moving along. I know there's a large window going here, but I've added temporary studs and fixed them with screws I can back out easily. So when the windows show up, we can measure them out and rebuild the rough opening underneath the top plate of our wall. The main reason why I put temporary studs in the wall is so I can get the roof built. So hopefully by the end of today, I'll have some rafters laid out on the top of our roof structure.
The first step in building the last wall vertically in place was to make sure the two standing walls were completely vertical and plumb. Then lock them into place with 2x4 braces. I then established the angle we need to cut the studs at to account for our raked roof. After transferring this angle to my saw, I cut the studs for each end of the wall and then cut the top plate. I'm gluing the studs for each end of the wall because later in the building process we'll be connecting beams to the overhanging awning on these corners. I then added the rest of the studs for the wall, starting in the center and working my way out and leaving a gap for the door that'll be showing up later. Before completing the framing details on the opposite wall, I need to do some final calculations for the rafter we have temporarily in place. By setting it into its final place on the two walls, I can set some plumb lines with my level and pencil. This will be a guide for the bird's mouth cutouts we'll be doing for all 14 of the rafters. I remove it and put it aside on my sawhorses. Later I'll be turning this into a template for the rest of the rafters. Because the design of our studio has two eaveless walls, this end wall has a rafter directly on top of it, so is technically a non-supporting wall, as the cantilever rafter carries the weight of the roof. This is why it has a different framing configuration from the previous wall we completed. I cut a small stud to size with the angle that'll support the top plate for this wall. I then fill out the top of the wall with stiffeners to help support the final rafter of our roof.
Oh, I will open up my eyes so I can see the light. Oh, and I'll try to spread my wings so I can fly. Oh, and the darkness starts to fade. Feels like things are gonna go my way. I'm gonna look sunshine in the day.
After all the framing's complete for this wall, I do one last double check with a string line and some packers to make sure the rake of the wall is completely flat and plumb in preparation for the rafters we'll be laying later. We'll be constructing our roof frame out of 6 metre long, 190 by 45 mil pieces of structural timber. More than half of our rafter material needs to be used in continual lengths to create the cantilevered awning overhang on the front of the building. The rest of the rafter material will be used as blocking for structural support between the rafters, and these pieces will be cut into much shorter lengths. So an important part of our preparation is to sort through all our rafter material stock and establish which pieces are the straightest so they can be used for the continual lengths of timber for our roof structure. We've laid out all the rafters on the driveway so I can check the crown for each one and mark them accordingly with my pencil. I use a simple system of drawing a bent line in the direction the wood's curved. This way later in the process I can easily reference which way the wood is naturally bent. After completing the crowning process for all the timbers, I move on to the next step of marking out where we'll be trimming the rafters to get them closer to their final length. I've cut a template that represents the final length of the rafter. This way I can slide it back and forth over the stock piece and decide which end to trim off. After marking and trimming all the timbers, we neatly stack them closer to where we'll be needing them for the next step in our process.
I'm gonna let the past be filled with smoke, and I will try to fix what has been broken and take this weight off my shoulders, 'cause I know yesterday ain't coming back. I'm gonna let the past stay in the cold.
Before we start cutting all the rafters to the exact size, I'm going to check our template rafter fits all the way across the length of our roof. The safest way to do this is to check the rafter in its true position. The rafters are fixed to the walls at 2 points. One end sits flush with the lower wall that's eaveless, and the other end sits on the higher wall for the cantilevered overhang that'll create the awning for the north side of our studio. It looks like the rain is settling in for the day, so I'm going to reconfigure my temporary shelter. This way I can create a rainproof space that's big enough for the 5.5 metre rafters. My system for cutting the 14 rafters is to clamp the template to the uncut rafter and transpose the notches across from one side to the other. The notch for the high wall that creates the cantilever is quite shallow, so I'm using a handsaw for a more accurate cut. After doing a series of cuts about 10 mm apart from each other, I remove the excess material with my chisel. End of the rafter, I use my set square to mark out lines so I can place my saw guide in the right place to slice off a small piece of the bottom of the rafter.
Oh, I will open up my eyes so I can see the light. Oh, and I'll try to spread my wings so I can fly.
Because our roof rafters are going to be exposed in the final version of our studio, it's practical to paint them before assembly. I'm applying a primer undercoat and 2 coats of the green my client has selected. It's a lot easier painting materials like this on a sawhorse than it is in their final position.
Now everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it.
Before adding the weight of the rafters on the top of our walls, I want to complete some engineering elements. The most effective way to keep walls square and sturdy is to add diagonal cross bracing. I'm installing this bracing in the last stud void of each wall. To start this process, I'm removing the temporary cross braces so I can re-rack the walls into perfect vertical plumb. The temporary braces I'm removing now kept the walls square during the process of bolting and gluing them to the concrete. An effective way of adjusting the square on our walls is to use a ratchet strap secured on the diagonal. This way I can easily adjust the amount of tension I need to pull the wall into vertical plumb. I have my spirit level clamped to the end of the wall, so I can easily tell when the wall's adjusted into complete square. When I'm satisfied the bubble in the level is completely vertical, I do one last double check on the other side of the wall before moving on to the next step. I'm starting the bracing panel with a centerpiece that's in alignment with the blocks in the wall next to it. I'm using liquid nails and 14 gauge heavy timber screws to make a solid connection. By combining horizontal blocks with blocks set at 45 degrees, the wall will remain solid in its square position. When the bottom half is complete, I add a temporary brace to stabilise the wall whilst the glue dries. I can now remove the ratchet strap so it can be used on the next wall.
Come closer, dance for me. Easy, tiger, easy, let your hair down. Come closer, let me see all your million faces and all your million mistakes.
For the next stage of our construction, we need access to the top of our walls. So I'm going to improvise some scaffolding with materials we have on site. I'm using a combination of pallets that some of the material is delivered on, and some planking I won't be needing until close to the end of our build.
Can I go to sleep, buried in my chair? The only thing that's left.
Because of the design aspect of having an eaves roof on the south side of our structure, all the tail end of our roof rafters need to be cut flush with the wall framing. The most accurate way to achieve this is to hang all the rafters in place on top of the roof. This way I can temporarily secure the rafters to the top of the wall and scribe the cut-off with a spirit level. This will ensure we get a completely flat transition between the wall and the roof elements when we add the sheeting material later. After marking where the tail of the rafter will be cut off, I number it so we can return the rafter to its correct position later.
Breaking feedback. Oh yes, I'm gonna stay right here. Stay until it disappears.
When all the rafters have been positioned for scribing, I move on to moving our temporary shelter for the last time. I'm using my wrecking bar to leverage it up so we can fit the small pieces of pipe underneath the walls and then roll it out of the way. I have windows arriving tomorrow. I need to get the temporary shelter in its final position so we can keep the windows out of the weather until they're ready for installation. I've added some 2x4s to the temporary shelter so we can securely strap the windows to them to keep them safe from the wind. We're also adding a lot of packing material to keep them protected. The final step is to wrap them in a tarp so they're waterproof until we need them. With the windows secured, we return to working on our roof frame. The roof frame has two timber elements, the rafters and the blocks that go between them. The blocks are cut out of the same stock material we used for the rafters, which is 190 by 45. I'm cutting them out of the 6-metre planks that weren't straight enough to be used for rafters. I need to cut over 50 blocks at a length of 554 millimetres. The most efficient and accurate way to do this is to set up a saw stop on the bench. I start this process by cutting a template piece at our 554 mil. After the cut, I double check it with my tape measure. After establishing the template block is exact to the millimetre, I secure a block of timber to the saw bench with a clamp to work as a gauge to enable me to cut the 50 blocks accurately and easily. I stack them off to the side for use later when we're assembling the roof frame. To trim the rafter tails, I've set up a production line so I can efficiently cut them all in one session. I've picked a location on the job site to make it easy for us to put the rafters back on the roof when I've completed the cuts. To set up for the saw guide, I make marks 100 mil to the side of where we scribe the rafters on the roof. I align the saw guide to the pencil marks and double check the measurement, clamp it in place, and then make the cut with my circular saw, holding it firmly to the edge of the saw guide. After completing the cut, I move the rafter off to the side and repeat the process on the next one. After the painting of the rafters is complete, I start preparing for their installation. We've been using the temporary shelter to get the blocks painted during the recent rain.
Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you
After stacking the pre-painted blocks in a convenient area for our assembly, we start the process of putting the rafters back on the walls. Once our rafters are returned to the original numbered position, I use my clamps to hold them steady whilst I fix them in place with our heavy 14 gauge timber screws. We're adding one of the blocks we prepared earlier between each one of the rafters on the eaveless side of the wall. When we complete the whole eaveless side of the wall, we'll be adding blocks to the cantilevered overhang section of the roof. You can see how I have a scrap piece of timber attached to the top of the block to help lock it and keep it in position whilst we clamp it in place between the rafters. I use my rubber hammer to tap the block into alignment and then fix it in place with one of our screws.
Tonight we'll turn minutes into days, and nothing's gonna make me look away. Peel off a layer and breathe. Lift up your head and lead. Count the stars before you leave.
When working on my own like this, I use a lot of clamps to hold the materials in the exact position whilst I fix it in with a screw. When the raft is secure, I remove the clamp and the temporary piece of timber on the top of the block and then move on to the next rafter and repeat the process.
Peel off a layer and breathe. Lift up your head and lead. Count the stars before you leave. Save a kiss for the breeze. Try to reminisce over me. Know that I will cherish your memory.
With all the blocking complete on the southern wall, we move our attention to the north wall with the cantilevered overhang and start adding the blocks there. Here you can see how the scaffolding we built earlier enables me to stand it at a convenient position for the assembly of these blocks on the front cantilever. This large clamp I'm using that spans 2 rafters is an important part of the assembly process. Wide planking material, like the rafters are made out of, always has slight cupping on the surface due to the wood grain. To account for this, I use the large clamp to create as much compression as I can between the 2 rafters. By repositioning the clamp for each fixing point, I ensure there's no gaps between the 2 rafters and the edge of the block.
Quiet voices in the night. Time is running out of sight. A lonely wind is passing by. Tries to carry all the whispers that it finds. The walls are listening when we talk, making echoes as we walk. There's no one left but you and me. It's like a made-up place that only we can see.
With all the blocks installed on both supporting walls, I set up a string line to check the alignment before moving on to the next step. To cover the gap between the block and the wall on the high side of our roof, I've screwed and glued smaller dimension blocks that sit in between the rafters and connect to the top of the wall plate. This adds extra strength to the cantilevered awning that'll experience heavy wind loads. Another part of adding reinforcement between the walls and the roof is adding purpose-made brackets. After attaching the bracket in the appropriate place with the small spikes provided on the bracket, we add specialised galvanised nails.
As a young girl, the fields were mine. We played hide and seek for hours, raised our shadows among the pines.
After attaching brackets to all the rafters at both ends, I add some additional bracketing to connect the studs into the top plate of our wall. I'm only adding these brackets in the corner of our building. The idea is by having extra reinforcement in the corner of the building, it'll help stop the roof being lifted off in a heavy wind event.
Daydreamer, kidnap me.
piece of reinforcement for our corner was to use a heavy galvanised bracket that bolts the second last rafter into the top plate. With all the reinforcement elements installed, we can start adding the next row of blocks. These blocks are seen from the inside along the top edge of the ceiling, so we've painted them green so they'll match the rafters. I'm installing these blocks the same way we installed the previous blocks that are painted black because we see them from the outside. I'm using 3 clamps and a temporary piece of timber on the top of the block to lock it in squarely between both rafters, and then add the 14 gauge timber screws. Once it's secure, I remove all the clamps and move on to the next block.
Every step, every breath for you. My head's up over the clouds for you. If there's a valley, I'd build a bridge so you could get by.
With all the blocks complete on this end of the building, we move our attention to the eaves side of our structure. Here I'm adding the blocks that will fill out the middle of the roof to support the marine ply sheets that we'll be adding later. They're laid out in 1220 centres because the marine ply comes in that dimension. Standard sheeting material in the metric world comes in 240mm by 120mm dimensions. But sometimes we end up with materials from imperial measurement countries like America, so it ends up with a larger dimension than our standard. And in this case, we're taking advantage of that. With the slightly larger dimension imperial sheeting, we'll be able to cover the whole interior of our ceiling with 3 sheets. Here you can see how later in the project we'll be installing the marine ply panels in a brick pattern layout. This adds a lot of strength to our roof structure. So the blocks we're installing now will support the edges of all the marine ply sheeting.
Yesterday there was sun and there was rain, beauty in the mundane. And as the light startled us, we let go of disguise. And now there's something in the air and a sparkly shimmer on our skin.
I have over 50 blocks to install that'll be visible from the inside of our structure, so they all have to be painted green to match the rafters. To facilitate this, I've set up a painting station under our temporary shelter. Here I've got about 20 blocks lined up on some planks as a way of efficiently getting them all painted. This way you can paint one facet of a block all the way along the line, and when it's dry you can turn them over and paint the other side.
Hand in hand, building castles out of sand, reaching for the grand. As willows align, we lose track of time. Head up high, now we climb.
Because of the limited space we have protected from the weather and rain to do our paint preparation, I work in batches. As soon as the paint is dry and solid in one batch, I install them so I can make room for preparation for the next. I'm installing the blocks in continuous linear rows. This is a way of ensuring that we keep the rafters parallel and square. Because of our strategy of pre-painting as much of the material as possible before installation, I'm constantly preparing material about a week before I want to install it. Here I'm sanding and priming the beams that'll hold the roof up on the open area at the side of the art studio. I ordered custom-built laminated hardwood beams so they'll be able to hold up the roof load that's on top of them. They're 90 by 190 millimeters and 2.4 meters long. I'm giving them a light sanding all over and rounding off the corners before priming and painting them.
Peel off the layer and breathe. Lift up your head and lead. Count the stars up before you leave.
Last week we completed the principal framing of the roof that'll be the inside part of the studio. We'll be building the outside veranda awning section next week. Yesterday we got this last rafter locked in place. This presented a few design challenges because we don't have any eaves on this side of our studio or on the back side of the studio. So I had to set this rafter in a specific place because it has to meet up with the wall we'll be adding later. And you'll be able to see when we're finished how this rafter matches the plane of this wall that comes down the side of our studio.
When the exterior foam board insulation is added, and then finally the cement sheet and battens, you can see how we achieve a crisp, eaves transition between the wall and the roof. With the framing complete on the west side of the building, I'm turning my attention to the east side. My client wanted a covered entertainment space on this side of her studio, so I'm using a post and beam construction system to extend the roof line 2.4 meters over this open area. The beam connects to a checkout at the top of the post, secured with 4 12mm bolts. To prepare the post and beam for assembly, I'm building a temporary bench to do the checkout on the top of the post that'll connect the beam, and on the bottom of the post for the brackets that go into the concrete footing. I'm adding some foam paper to our temporary bench to protect the pre-painted finish to the post and beam whilst we work on them. I start the preparation for cutting out the checkouts in the 2 posts by calibrating my saw. I'm making sure the blade is set at a true 90-degree angle, and the depth of the cut will be at 90mm, which is the width of our beam. After setting up the post on our temporary bench, I use my tape measure and speed square to mark out the cut lines. After completing all the pencil marks on the post, I do one last double check with my tape measure on the structure to make sure we're not going to cut it in the wrong place. The posts and beams we're using were custom ordered and took weeks to get here, and I have no spares. So it's important I double check my measurements before making a cut.
Say that kiss pretty please. Try to reminisce over me. Know that I will cherish your memories.
After cutting the post to length, I sand the edges smooth, then transpose the measurement of the beam over to the post in preparation for the checkout cut. Here you can see how I'm using my speed square as a guide for the saw to make an accurate 90-degree cut. I then make multiple cuts at roughly 10mm intervals to make it easier for me to chisel out the checkout.
Feel off the air and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss pretty please. Try to reminisce over me. Know that I will cherish your memories.
I use my speed square to make sure I've cut the checkout to the correct depth. Then place the beam inside the checkout in place to make sure it fits properly. I use my spirit level to confirm that the beam is sitting completely flush with the post, then prepare to drill the holes that'll connect the two together. By placing the washers over the pencil marks for the drill holes, I can confirm that we'll have an appropriate bolt layout on the beam. The first hole I'm drilling is to house the countersunk bolt and washer. I test fit the washer and bolt to get the appropriate depth for this hole.
Turn around and show your face. Let me see parts of you. Oh my, our bodies interlace, flowing easy.
I've changed the drill bit to a 12.5 diameter for drilling the holes that go all the way through the beam and the post for our 12mm bolts. The important thing to remember when drilling these holes is to try and keep the drill at a true 90-degree angle to the beam. This way our holes will line up properly on the other side of the post. When all the holes are drilled, I remove the beam and clean out the holes in the post. Then check that the bolts can fit cleanly through the holes for assembly later on. With the checkout complete on the top of the post, I set up to do the checkout for the bottom of the post that allows the brackets that's set into the concrete to connect into the post neatly. I'm using the bracket as a template to mark out where we'll do the checkout and how deep we'll make it. By having all the cut points accurate and clearly marked, it avoids making mistakes once you get the cutting tools involved.
We will dance away the gloomy days right here. We have silver lights, what a time you and
I duplicate the process on the other side of the post, then use the bracket as a template to drill the holes through and fit the bolts.
hand in hand, every night. And I will watch you, breath after breath, hold on, so beautiful. And if you fall, I will catch you. We will dance away gloomy days right here.
With all the cutouts complete and holes drilled for the first post and beam, I duplicate the process on the second ones and then prepare to finish the painting on them before installation. The main reason I go to the trouble of pre-painting the materials is to protect them from the weather before we get the roof on to cover them. Having the checkouts at the top of the post painted also helps stop dry rot occurring between the connection points of the post and beam. This will extend the life of the structure. Because the rain looks like it's setting in, I'm going to extend the tarpaulin in our temporary shed to give us some shelter from the weather whilst we finish the painting on the post and beam.
Give me tears so I can cry. And give me heart so I don't die. Give me tears so I can cry.
Another place that can be vulnerable to dry rot are the countersunk holes for the bolts and washers. With the posts and beams ready for assembly, I need to construct a temporary scaffold to help seat them in the concrete footings. I'm building the scaffold out of framing material we'll be using later in the project. We're making good use of our temporary rain shelter and are able to carry out most of the work under cover.
Give me heart so I don't die. Give me tears so I can cry. Give me heart so I don't die.
There's many ways you could set a post and beam like this, but because I'm working by myself and I'm trying to keep costs down, I'm choosing to build a temporary step ladder. This way I can safely and slowly walk the beam up to the height I need it. Before I secure the last piece at the top of the temporary scaffold, I double check with my spirit level that the beam's going to sit completely horizontal. I add a couple more steps to my ladder system to make it easy for myself, and then start the process of walking the beam up into place.
Mud on your boots tell the story of where you've been. Travel, beat up, warning with settled soul. Trust your gut, you have earned at least that. Age has proven to be kind.
After securing the beam with some clamps, I double check that it's sitting perfectly horizontal, and then set up a string line to make sure it's in alignment with the wall it's going to be connecting to. With everything aligning properly on our first beam, I repeat the process for the second beam. This will be a little easier because it's not set quite as high.
Love heart is not in vain. Scarred by the good fight. Weathered skin from the sun. We're proud you have lived well.
With the beams set in place and completely level, I secure them to our walls using a heavy bolt and a flat bar washer. I'm only adding one bolt at this time, so I can allow for adjustment when we're setting the concrete on the post. Before hanging the post off the end of our beam, I attach the bracket that'll be seated in the concrete footing on the bottom of the post. After raising the post and setting it in the hole for the concrete, I need to align the top of the post and the beam so I can get the bolts to go through the holes we prepared earlier. These bolts are purpose designed to jam into the timber when you hammer them in. This way they won't spin when you tighten the nuts.
9 to 5 was my dad's advice. Don't think twice, I want the luxury life. My beauty can lose it, I'll use it. I'll take what I want.
With our post hanging from the beam completely vertical and plumb, I add a few braces at the bottom and start the process of adding the concrete footing.
Spending a Sunday at the gym, trying to fit in. Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of ticking, not enough time, not enough time. A whole lot of sweat, trophy wife, trophy wife.
As the first post sets up in the concrete footing, we get started on the second post. One of the advantages of setting a post with this system is you can hang a string off the end of the beam with a weight on it to calculate where you need to dig the hole for the footing. The concrete foundation for this second post has to be significantly larger, as the post on the high side of our studio has to carry the weight of the cantilevered overhanged awning. I'm using a combination of the wrecking bar, post hole digger and shovel to excavate this hole. I'm trying to keep the excavation as clean and tidy as possible, as due to the wet conditions, all the soil's extremely muddy and sticky.
Not enough time, not enough time. A whole lot of work for this trophy life, oh, a whole lot of thinking behind these eyes.
Because I'm pouring such a large concrete footing, I'm adding some steel reinforcement to ensure that it doesn't crack and subside over time. As part of securing the beam to the existing wall, I'm adding a 2x4 that sits underneath it, creating a ledge for the beam to sit on. After checking the 2x4 has a nice tight fit, I add liquid nails glue and secure it with 14 gauge screws.
Slow traffic cause me a stress. Show no panic, I'm just born in a dress. And I know that I'm older, I'm done. I'll do what I want, I'll do what I want.
With the beam secured to our wall, we're ready to hang the post off the end of it. I have the post resting on scrap pieces of timber to protect our paint finish as we add the bracket that'll be set into the concrete footing. All the work we did earlier pre-fitting this bracket on the bottom of the post helps this process come together easily.
Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of ticking, not enough time.
With the post firmly attached to the beam, I make some final slight adjustments with a wood wedge to make sure the beam's completely horizontal. To secure the post in its vertical position, I'm adding some scrap bracing at the bottom to hold it in place. When I'm satisfied the post is perfectly plumb and vertical on both planes, I start adding the concrete in the hole we prepared for the footing.
Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true. No matter where I go, I'm coming home to you.
step in finishing the concrete footing is double checking that it's at the right height for paving that'll be coming much later in the project. I do one final check with my level to make sure the post is completely vertical and plumb in both dimensions, and then let it set up overnight.
I have seen many places where the beauty never ends.
We'll be installing the last of the roof rafters and completing all the framing elements to finish the roof. But first I need to remove the temporary scaffold we used. To help keep the two beams secure and parallel, I'm temporarily clamping a rafter over the top of them. Until we complete the framing for this section, there's nothing really holding the front and back beam and post together.
Over and over, injustice to injury. This is a part of it all. Could you hike back to it, fight with it, sit with it? This is a part of it all. Ask around, be aware, make peace with what is there.
All the 190 by 45 framing material I used for this scaffold is going to be used as blocking for this section of the roof. This is another way you can help cut costs in your construction. After the rain eased up, I installed some framing brackets to help tie the beam into the main part of our structure. Although I've used two 12mm bolts to anchor the beam into the wall frame, I wanted to add additional bracketing to help mitigate against the heavy winds we have in our area and help ensure that this point stays connected for the life of the building. The rain's too heavy to do any construction, so I'm prepping the blocks we'll be needing for the completion of the roof frame. The temporary rain shelter I constructed has been invaluable for keeping the project moving during these wet winter months. After the storm passed, I returned to adding blocks to the edge of our roof structure. These blocks are needed to hold the outside edge of our marine ply sheeting. Because our roof is slightly larger than 4 sheets of marine ply, I'm adding these edge blocks to both sides of the roof. I'm attaching them with the same 14 gauge screws we've been using throughout the structure. I'm adding a screw either end of the block through the rafter and 2 screws through the vertical block that's already in place. And because these blocks will be exposed on the inside roof, I've painted them the same green as our rafters. Once all the blocks are complete on the lower side of the roof, I repeat the process on the high side of the roof with the same dimension blocks, which is 70 by 45. Here you can see how the scaffolding I erected earlier is making this task a lot easier than having to work off a ladder. Later in the process, when we're adding the marine ply sheeting, you'll see how these edge blocks enable us to use the full width of the sheet on the layout. The inside edge of the marine ply sheeting gets fixed to the blocks that we're adding through the centre of our roof in between the rafters. The other reason for adding the 2 rows of blocks through the centre of the roof is to stop the rafters twisting over the 4-metre span. My process for installing these blocks is to use the large clamp to add compression to the rafters holding the block in place, and then add 2 of our heavy 14 gauge timber screws. I then add another 2 screws to the other side of the block, but these are drilled in on an angle. This is where it's important to use a pilot hole to ensure the screw stays in the correct alignment and doesn't poke out the other side of the block. With the block fixed in place, I remove the temporary piece of timber on the top of the block that's been holding it in alignment with the roof plane, reposition the clamp and repeat the whole process.
Now everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it. Everything that has been don't matter no more. We've burned it.
With the roof frame complete our structure, I start the process of hanging the rafters in the section that'll be open on the side of the studio. We've pre-painted these rafters as we did with all the timber material that'll be seen on the final build, so we're taking extra care to protect the paint as we position them on the beams.
Your eyelids and perfect lips got me rushing, panning, I'm so lit. Like lilies you open, the fragrance goes to my head, my darling, I
The
get.
first step in this installation is to copy the wall and block layout from the existing rafters onto the new rafters. After making sure they're perfectly aligned, I transfer the layout onto one of the new black rafters. By transferring these marks with my set square to the other two, I'll ensure that all the blocks line up for the sheeting that we'll be doing later on. I then start fixing the rafters onto the beam, working from the outside into the middle. I add the same pre-painted blocks as we've used throughout the construction of our roof frame. These blocks are 554mm long, which creates a 600mm centre for the rafter layout.
We're getting close to completing the framing for the studio. The next section we're going to construct is a bridging point between the inside and outside of the roof. All the rafters lay across the two walls, except for this point here. We're actually putting blocks that are twice the length, where the outside and the inside wall have a kind of hinge point. So we actually double the size of the blocks. The idea is to add some more engineering strength on this hinge point between the roof that's on the open area and the undercover roof, which will help avoid uplift in the wind. Because this whole open roof is a bit like an airplane wing with its flaps up. We get really strong winds from the north. So I'm trying to add as much reinforcement into this structure so we don't get any uplift and the roof peeling off in a big storm. I've pre-cut and pre-painted all the pieces necessary last week, so today we're going to be installing them.
I want to take you back through the process of how I prepared these double-sized blocks. The first step was to cut the blocks to the appropriate length. Although this should be a formula cut, due to variations in our timber and the framing process, I'm custom cutting each block to fit perfectly in place. The next adjustment to be made is to make the double-sized block fit the existing plane of the roof where the sheeting will be attached. I use a packer to establish the block is sitting 5mm too high for the roof plane. I then use the same 5mm packer to scribe a notch mark where the block sits on the wall. These pencil marks will act as a guide of how much material I need to remove from the block for it to sit flush with our roof. I've clamped the block to one of my sawhorses for stability, then use a handsaw and chisel to remove the 5 to 6mm of material needed. I make a series of cuts 5mm deep with my handsaw. This helps me keep an accurate depth when I remove the material with the chisel.
Let's get out, we can leave this city. Let's drive to the open air. Yeah, the countryside is so pretty, with the wind blowing in your hair. We can look back someday, baby, don't you understand?
After all the carpentry is complete on the double-length blocks, I place them under our rain shelter for painting. While I'm waiting for the paint to dry on our blocks, I return my attention to the new black rafters we laid on the beams. I'm adding heavy galvanized brackets with 12mm bolts to help hold the rafters in place with the heavy wind loads they'll be experiencing. After clamping the bracket into the correct position, I drill pilot holes for the screw thread bolt that's going to go into the hardwood laminated beam. I go to extra trouble to make sure the pilot hole drill bits are the correct size for the thread on our bolt. But if the pilot hole's too small and I have to over tighten it, you can snap the bolt head off in the bracket, which is what we don't want to do.
Hey darling, can I tell you what's been on my mind? Sick and tired of the 9 to 5 in the city life. Hey darling, we could get out of town, see the beautiful world around, wanna see it now.
As part of achieving an eaveless roof and wall edge on the lower wall of our studio, I'm installing these unpainted 70 by 45mm blocks along the edge of the rafters. They don't need to be pre-painted like our other blocking material, as these will be buried under the wall and roof sheeting and won't be seen in the final build. With the blocks on the lower wall complete, I move my attention to the other side of our roof structure, where we need to add blocks to the outside edge of the overhanging eave. It wasn't practical for me to build a scaffold for the installation of these blocks, so I'm doing it from the ladder. I'm using the same system I've used to install all the blocks on this roof frame, which is having a scrap piece of timber on the top of the block to keep it in line with the roof plane, and then use my large clamp to add compression once it's in alignment, and then fix it in place with 14 gauge timber screws.
Look a little closer, it's been quite some time. You gotta let me know if I'm out of line. But there's some words that I just wanna hear you say, to put it all straight before this night turns into day, and then I'm on my way. Yeah. Yes, I'm on my way.
Now that the painting is complete on the double blocks, I'm ready to install them over the transition of the inside to the outside on the side of the studio. I'm installing these blocks the same way we've installed all the blocks on our roof frame, which is to have a piece of timber on the top of the block screwed in temporarily, so we can easily and efficiently set the top of the block to match the roof plane of the rest of the framing. Once the block's in place, I use my rubber hammer to make small adjustments to keep it in line with the other blocks. After doing a final check with my speed square to make sure it's completely vertical, I add the two 14 gauge screws on one end. I then add two 14 gauge screws to the other end, but these are drilled in on an angle, like I showed you earlier when we were installing one of the standard roof blocks. With the block secure, I remove the temporary piece of timber on the top of it so I can reuse it on the next block. Because these double blocks have been custom cut to the exact size, I use my large clamp to spread the gap between the two rafters so I can fit the block in easily, and then back the clamp off so it adds compression to the block to keep it tight and make it easy to adjust with my rubber hammer.
Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you leave.
With the double-sized bridging blocks in place, I'm now adding green painted blocking to create the inside corner edge of our ceiling as we have exposed rafters on the inside. Pre-painting all the framing material for this roof does create some logistical difficulties, but in the end you save a lot of time and labour, and in our case I needed to have the roof frame protected from the weather until I got the sheeting on, so it's worthwhile.
Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memory.
I'm now installing black blocks that are identical in length to the green blocks we just installed. This will create a false rafter on the outside of this wall that matches the rafter layout for the whole roof. The other rafters in our roof frame have to span from the low wall to the high wall, but this rafter lays along a supporting wall, so that's part of the reason why I've chosen to frame it this way. By reversing the block layout, we've added a lot of strength between the transition of the inside to the outside of our roof. With the framing complete for the transition from the inside to the outside of the studio, I complete the blocking for the outside section, These blocks have been pre-painted black so it matches the underside of the awning in the finished build. Although all the standard blocks for our roof frame are measured at 554mm, this doesn't always work out to keeping the roof square in the real world. Due to the variations in the thickness of the rafters, sometimes I have to make adjustments. I run string lines across the rafters periodically to check that they're lying straight and square. If the rafter starts to bow out slightly, I trim a millimetre off the next set of blocks down to 553, and this keeps the next rafter square and plumb. Because our outside section of the roof frame is going to be vulnerable to uplift due to strong winds, I've added bracketing to all the points where the rafters connect into the hardwood beams. I've used a combination of standard sheet metal roof ties and heavy angle brackets with bolts. With most of the roof frame complete, it's time to start adding some of the sheeting material. I'm using 6mm marine ply, which we're pre-painting before installation. The plywood panels will become the ceiling in the final build and be seen from underneath. So we're painting one side with clear polyurethane and the other side with black paint to protect it from the weather.
You master how to simplify. You turn rain into a blue sky. When the wind blows.
Whilst I'm waiting for more of the ceiling panels to be painted, I'm going to finish some of the details off on our false rafter. I'm filling and sanding the screw heads, then doing some touch-ups with the black paint we're going to be using for all the exterior of the building. Because of the clear polyurethane finish on the bottom of our plywood ceiling, it'll be a lot harder to add black paint later. Here I'm adding a small piece of 190 by 45 to create the tail of our false rafter. Because this is such a small piece of wood, I'm using liquid nails glue in addition to screws to secure it in place.
Sipping coffee under the apple tree. It's gentlemanly. Well, you're a good man, quite the best man, a real fine man. When the wind blows and the windows are closing, you let the world know that what has been has been.
With the tail of the false rafter secured, I'm now installing the head of the false rafter. I've set up a temporary platform to hold it in place whilst we secure it into the framing. After checking with my tape measure that it's sitting on a 600 centre that matches the rest of the rafters, I secure it with a clamp and then install the blocks either side of it.
I'm gonna let the past be filled with smoke, and I will try to fix what has been broken, and take this weight off my shoulders, cause I know yesterday ain't coming back. I'm gonna let the past stay in the cold. I will listen to the ocean, let its unsaid words be spoken, and I'll let my mind be carried by the waves.
I only have limited space for the preparation of the marine ply ceiling panels, so the plan is to install them as they're painted and prepped. Ready to install the last rafter that sits on the end of the roof frame over the two posts we installed. I start by pre-installing some heavy steel brackets that'll help secure it to the roof frame. I'm using 12mm bolts to attach the angle brackets to the rafter. These are going to sit on top of the hardwood beams that are attached to our posts.
Breaking feedback.
some assistance to secure the last rafter in place. I double check that it's aligned with the rest of the rafters, use my clamps to hold it in position, and then bolt it to the hardwood beams.
One way, gonna lay down, be still, won't waste another tear. Wait till it disappears.
With the final rafter securely in place, I add the last of the blocking to complete our roof frame.
I know you wanna give me some, and I would wait for someone else to come. Oh, it's sad, but it feels right. I'm just hallucinating now. This is the final I just take a bow. While it all falls apart, guess you can't win them all. Oh no, oh no.
We'll be adding the OSB wall sheeting and membrane, but first we have to add the rough openings for the doors and windows. To save money on our build, my client chose to purchase factory second doors and windows instead of new ones. They arrived on our job site a couple of weeks ago, so now I can accurately build the rough openings for them. To help accurately position the door and window on this wall of the studio, I've created timber templates out of framing material. This way I can adjust the position back and forth until the client's satisfied where she wants her door and window. By establishing a center point for the opening, I can accurately build the rough framing that'll fit the windows we have on site. I always work with wood templates for the width of the window, as it avoids mistakes that can be made with your tape measure. With the window and door clearly marked out on the top and bottom plates of the wall, I can start removing the temporary studs. Because I had a general idea of where the door and window was going to go when I framed this wall, I was careful to make sure the studs were going to be easily removable for this part of the process. Once the king studs are set in the correct position, I add the cripple studs that'll be holding the lintel or the header in place. The king stud on the right hand side of this door happens to align directly next to one of the standard studs, so I'm using liquid nails with screws to attach the king stud to the standard stud for a solid door frame. With the king stud secured, I add the lintel to the top of the opening. In this case, I'm using a piece of 190 by 45 for the lintel material. I use one of my clamps to help hold it in place whilst I set it in the right position with my rubber hammer. I then secure it in place with the same 14 gauge timber screws we've been using throughout our framing. I then add a second piece of 190 by 45 to the inside of the doorway. Besides adding a lot of strength to the lintel, it'll also create the framing plane for the inside sheeting that'll come later.
As a young girl, the fields were mine. We played hide and seek for hours, raised our shadows among the pines. So offshore, playful and free, without a care in the world. I was one rich little girl.
With the first door frame complete, I used my reciprocating saw to cut the bottom plate out. This will make it a lot easier to sweep the water out that's been building up on the slab due to all the rain.
We spent summers catching fireflies and winters on our skates. One big smile across my face.
The rough frame for the window opening in this wall is going to require a different approach due to the 3-meter width of the window. I need to set a temporary beam that's wider than our window opening to help hold the roof up whilst we remove the unneeded studs. I clamp the beam tight up against the roof rafters until I fix temporary screws to hold it in place. I add half a dozen 14 gauge timber screws through the beam into the top plate and then add a temporary stud in the centre of it. It's now safe for me to remove the temporary studs from the wall and add the king studs that'll define the edge of the window. The wall studs come out easily because I fixed them in place with a screw on a 45-degree angle, so they can be easily removed at this stage of the process. I do one last double check with my tape measure before I cut the lintel to size. I ordered a custom-made laminated beam for this opening due to its extreme width. I don't have any spare material for this beam, so it's always worth double measuring and even triple measuring for cutting a unique piece of material like this. I set this window lintel the same way we did the door lintel earlier, taking extra care to make sure it sits flat on the plane of the outside of our wall.
Daydreaming is my new middle name. This is not a game for me. Imagining is my new best friend, and rain's all I see. I gotta be in love. My heart covers every degree.
After installing the studs that sit underneath the lintel, we can remove the temporary beam we set up earlier. For a window this size, we double up the cripple studs that sit under the lintel for extra strength over the width. I removed the screws we used in the temporary beam and put it aside for later. I'll be using some of this material for lintels in the other windows. To complete the window frame, we need to build a short wall that'll be sitting under the window and supporting its weight. The framing pattern is the same as the rest of our walls, which is 600 on centre, so I've cut 6 identical studs at 900 millimeters and start installing them on both sides of the window. I measure and cut the sill and then install the other 4 studs on the 600mm layout, matching the rest of our wall. All the door and window rough openings we're building are built 20mm wider and 20mm higher than the actual window. This way, when we install the window, we'll have a 10mm gap on all 4 edges of the window or the door. I then add some 45mm framing material to thicken out the lintel to match our 90mm wall. This will give me somewhere to attach the inside sheeting. The other 2 windows we'll be installing in the studio are identical to each other. They're 2.1 metres high and 1200 wide. I've added a temporary beam to support the roof whilst we remove the temporary studs like we did on the previous window. Here I'm using one of the studs that has to be removed and placing it in the centre of our temporary beam for extra support. I can now safely remove the final stud for our opening and install the king studs for the window. I need a tight fit for the king studs that connect from the bottom plate to the top plate, but not so tight that they push the top plate out of plumb. I use my rubber hammer to gently tap them into the correct position and then double check with my set square that they're sitting 90 degrees on the bottom and top plate. I'm using treated timber framing for the king studs and cripples of all the doors and windows, as doors and windows are never perfect and can sometimes leak, and this is often where rot can get started and then move throughout the framing of the wall. After installing the cripples and lintel, I can remove the temporary beam and reuse it on the next opening.
Yesterday there was sun and there was rain. Early in the Monday, and as the light startled our eyes, we let go of disguise.
Here I'm taking my time to trim down the king stud so it fits snugly but not too tight. It's important that we don't push the wall out of square when we're adding the new studs. Once the king studs are secured in place, I add the cripples that'll support the lintel over the opening. I use liquid nails as well as our 14 gauge timber screws to attach the cripples to the king studs, as this is what the window will be attached to, so I want an extra strong connection into the framing. Here I'm installing screws at a 45-degree angle through the cripple into the bottom plate, as all the weight from the roof gets transferred to the lintel, then down to the cripples and into this bottom plate. With this window rough opening complete, I can remove the temporary beam.
Dream,
final opening we're preparing is for a doorway under the open awning area. I've set up some scrap timbers to create a ledge so I can place the lintel in the correct position easily and fix it in with our heavy 14 gauge timber screws. I then glue and screw the cripples under the lintel into the floor plate, using my clamp to help keep it in line with the exterior plane of the wall. To complete this doorway opening, I cut the bottom plate out with my reciprocating saw flush to the cripples. This completes the rough openings for all our doors and windows. One of the last things I need to do in preparation for sheeting the walls is add horizontal blocking at 1200 and 2400 heights. This is an essential part of the strength of the framing and also creates an overlap point for sheeting material on the outside and inside of our walls.
Peel off the layer and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memories.
Last week we completed all the framing for the doors and windows so we can move on to sheeting our walls. Unfortunately, we discovered we had a problem with our plywood ceiling panels. The bottom of them is covered with polyurethane so they look like natural timber, and the top is painted in black because we had plenty of black paint. Unfortunately, it's leached through the plywood, so it's ruined the finish from underneath. So we're going to have a completely different approach of how we deal with these ceiling panels. I left this panel in place because we're still going to put the fascia on the front of this roof, so it might be handy for standing on. My goal this week is to have all these walls sheeted with our bracing ply.
Because of all the pre-painted elements we're using in the roof frame, this is often what determines when it's time to install something. With that in mind, the last final element of the roof, which is the fascia that runs the entire length of the building, is painted and ready for installation. Our roof is 8.5 meters long, and the 190 by 45 material we're using only comes in 6 meter lengths, so I'll be using 2 pieces to cover the span. With a combination of some temporary timber bracing and my clamps, I maneuver this first larger piece into position. When the fascia is aligned with this first rafter, I start adding our 14 gauge timber screws. I'm using 2 different length screws for this installation. I'm using 100mm screws that go into the blocking we added earlier, and I'm using 150mm screws to go into the rafters. I use my clamp to hold the fascia flat to the roof frame whilst I secure it with our 14 gauge timber screws. Moving from one rafter to the next. As each section of the fascia becomes secured, I remove the temporary timber braces that were holding it in place. The 2 pieces that make up the fascia are joined with a 30-degree cut, which will help stop a gap developing over time. Once I've secured the end of this first larger piece of fascia, I install the shorter piece on the far end of the roof.
Tonight we'll turn minutes into days, and nothing's gonna make me look away. Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memories.
The installation of this fascia concludes the roof frame. Later I'll be filling these screw holes and touching them up with black paint for a better finish. One of the passive house design elements we're adding to our art studio is creating an air cavity between the wall insulation and the outside cement sheeting that clads our building. The air gap between the insulation and the cement sheet is created by battens that have a vent at the bottom of the wall. So one of the important steps is to install a bug screen at the bottom of the wall so no insects and termites can enter the void. I'm attaching strips of fly mesh with my staple gun that'll wrap over the bottom of the battens later. I wanted to have this in place before we started putting our OSB sheeting on the walls. To ensure the OSB sheeting isn't damaged by moisture by the air vent that we'll be installing in the bottom of the wall, I'm using packers to create a 5mm gap that I'll be injecting Sikaflex into to create a waterproof connection point between the OSB and the slab. The OSB bracing sheets I'm using are 6mm thick, 1200mm wide by 2700 high. Here I'm using clamps to hold the first sheet in place while I scribe pencil marks for the cuts. I often find it easier to scribe the material in place and then be able to make an accurate cut. After checking this first sheet for fit, I apply a bead of liquid nails around the entire perimeter of the sheet where it's going to join the framing, and then secure it with my nail gun. An easy way to calculate the cut for the second sheet is to use the offcut from the first sheet, as it serves as a template for the 5-degree roof angle we need to cut on the top of the sheet. One of the reasons we frame the walls with our studs at a 600mm centre layout is so standard sheeting material like this OSB will lay across 3 studs without any adjustment necessary. My nail pattern is about 150mm between nails. Because of the extra layers of material we'll be adding to the wall for our passive house design systems, I need to leave room for other fixings that'll be coming later with the battens and the final sheeting. Gluing the OSB onto the frame with liquid nails can get messy if you're not careful. So I'm using a system where I lightly tack the side of the sheet in the correct position on the framing. This enables me to open a gap in the panel and add the glue down to the other side. Once I've completed the glue bead, I lightly tack this side to the frame, open up the other side and repeat the process. Once I've finished applying all the liquid nails to the frame, I hand nail the panel back onto the frame and then finish it off with my nail gun. To ensure all the nail heads are flush with the OSB, I go over our finished wall with my hammer to tap any nail heads flush with the sheeting. This completes the first wall. Tomorrow I'll start on the wall next to it that has the doorway and the large window.
Turn around and show your face. Let me see parts of you. Oh, my body's interlaced, slow and easy. I can reach you from a distance. I can, so beautiful. I can hear you within the silence. Ooh.
I chose to use orientated strand board as our bracing paneling because it's half the price of plywood. One of its disadvantages is it can absorb a lot of moisture. So when our panels were delivered, we sprayed them with a wood sealant. This ensures our OSB won't absorb any water whilst it's exposed to the weather before we get the roof on. There's a couple of good reasons for adding glue in addition to our nails for the panels. One is it adds a lot of strength to the structure. It helps attach the top plate into the studs and down to the bottom plate. This will help stop uplift in the building from strong winds. And in our case, we have this large eave on the high side of our structure. So by gluing the OSB to the frame, it'll help ensure that our roof stays on in heavy winds. Other good reasons for gluing the panels is it stops insects and micro drafts being able to penetrate the walls.
Give me tears so I can cry. And give me life so I don't die.
studio has a slightly different challenge on how we go about sheeting it. This last wall has a different framing configuration from the rest of the walls, as I needed to create supports for the bridging blocks in the roof we did earlier. Because this wall has a 5-degree rake in the roof, just like the first wall we sheeted, I'm able to use one of the offcuts from the first wall as a template. By aligning the offcut to the height of the wall, then double checking with my set square that it's completely parallel to the factory edge of the sheet, I can easily scribe the 5-degree angled pencil mark I'll need to cut this piece to fit the new wall. After cutting this sheet so it fits the framing configuration of the wall, I clamp it in its final position so I can scribe the cutout necessary for the doorway. Another way of achieving the door and window cutouts on the panels is to fix the sheet in place and then make this cut with a reciprocating saw. I prefer to scribe the cutout with a pencil and then cut it with my circular saw. As I achieve a smoother cut for the rough opening, this can make it easier for installing the waterproof flashing elements that we'll be doing later.
Mud on your boots tell the story of where you've been. Travel, beat up, worn in with settled soul. Trust your gut, you have earned at least that. Age has proven to be kind.
The last step in completing the installation of our bracing panels is to add the Sikaflex sealant to the bottom edge of all our panels. When we attached the panels to the walls, I used 5mm packers at the bottom of the panels to create a gap we could inject the sealant into. This is to protect the bottom edge of the OSB from getting any moisture into it, as the edges of OSB can be vulnerable to moisture penetration. I smooth out the Sikaflex bead with a packer to ensure I'm not leaving a bump in the wall plane for the elements that'll be added later. One last element I need to complete on the roof fascia we installed earlier is to trim the end of it off flush to the eaveless side of our building. Often with a long, difficult piece of material to install like this fascia, it's more practical to leave it a little long and then trim it off exactly where you need later. I then finish off the cut with my orbitable sander so I can round over the edges to match the rest of the framing material. The last thing I need to prepare before adding our membrane is to cut a rough opening for a pet door we'll be installing on the side of our studio. I aligned my drill from the inside of the wall to create holes in the 4 corners so my jigsaw could complete the cutout. Once the cut is complete, I smooth off the edges with my sander and then coat the exposed edge of the OSB with liquid nails to help protect it from moisture. The wall skin of our studio is made up of 4 elements: 6mm orientated strand board for strength, breathable membrane for waterproofing, foil board for insulation, and painted cement sheet to keep the elements out. And today we'll be installing the breathable membrane. I'm using a purpose-made house wrap that comes in a 2.7 metre wide roll. The floor of our studio will be a good place to cut and measure the pieces we need whilst keeping it relatively clean. I use the side of the roll as a straight edge to make 90-degree cuts in the membrane. I'm cutting my pieces slightly oversized so we can trim off the excess once they're stapled in place. I add a few staples to the top of the piece to hold it in place, whilst I add more staples to the bottom edge to secure it more accurately. I then continue to add more staples on the top and bottom to tighten up the membrane onto the wall. When the membrane is sitting flat on the wall, I start adding staples to the perimeter. I then trim off the excess with my Stanley knife and start applying the silver adhesive tape along the corner's edge. Managing the silver tape can be tricky as it's extremely sticky and will stick to itself quite easily. With the left-hand edge secure to the corner, I can stretch out the right-hand edge and staple it flat to the wall. I use my straight edge and Stanley knife to trim off the excess and then add more silver tape to seal it in place.
Spending your Sunday at the gym, trying to fit in. Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of ticking, not enough time,
I continue to use the same process of slightly overcutting the size of the pieces I'm using so I can trim them down after I've got them tight to the wall with my staple gun. When the membrane's flat to the wall, I trim off the excess with my straight edge. I'm leaving a 50mm gap on the edge of all the windows and doors as part of the flashing process that'll be coming later. The manufacturer of this membrane product recommends there's 150mm overlap whenever you're joining two sheets. I'm not adding any membrane material now to the areas above the doors and windows, as I'll be adding that later as part of the flashing process to keep the windows waterproof.
9 to 5 was my dad's advice. Don't think twice, I want the luxury life. My beauty can lose it, I'll use it. I'll take what I want. Oh yeah. A whole lot of ticking, but not enough time. A whole lot of work for a trophy wife.
With half our walls covered with the membrane, I continue the process on the other two walls, making sure to tape all the edges where the staple holes are. I don't want any staple holes in the middle field of the membrane to create leak points for moisture.
Spending your Sunday at the gym, trying to fit in. Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of ticking, not enough time. A whole lot of sweat for a trophy wife. The clock keeps ticking, still running out of time.
The next step in our project is to create a window buff for all the door and window openings. A window buff is an extension of the door and window frames. This is necessary for the air cavity rain screen we're installing on the walls. It allows the outside plane of the window to align with the cement sheet we'll be adding later as the final cladding layer of the wall. It also creates an anchor point for the waterproof flashing we need to make the windows watertight. The depth or thickness of the window buff is determined by the elements we're using to create the cavity rain screen, which will establish the thickness of the wall. Because we're using 25mm foil board insulation and 27mm treated pine battens, the window buff will need to be 40mm thick for the windows and 20mm thick for the doors. The windows and doors come from different manufacturers, and the flange on the exterior of the aluminium frame of the doors and windows is a different design, so that's why we have different buffs for the doors and windows. I've created a jig out of the same material we'll be using for the window buff frame. This way I can accurately scribe pencil marks on the wall, which will assist me in the measurement and installation of the material later.
But there's some words that I just wanna hear you say, to put it all straight before this night turns into day, and then I'm on my way. Yeah.
To achieve the 40mm thick window buff, I'm using 2 layers of 20mm thick pine glued on top of each other. To create an accurate fit for the frame, I start with temporarily installing the bottom piece, cut slightly oversized. By resting the vertical pieces on this first horizontal piece, I'm able to make accurate cut marks. I then cut and double check all the pieces for fit. Once I've cut all my pieces, I label them for assembly later. I start the assembly by putting the bottom horizontal piece in place, securing it with my clamps and adjusting it with my rubber hammer. When I'm satisfied it's in the correct position, I add 8-gauge countersunk screws to fix it in place. I then work my way around the sides and top of the frame, adding the other pieces. I'm using a combination of screws and liquid nails glue. When I was installing the wall membrane, I left a 50mm strip of OSB exposed around the edge of the window, specifically to give us a surface for the glue to join these frames to our wall. When the first layer of 20mm frame is installed, I add the second 20mm frame on top using glue and screws.
A bit naive and so eager to please. You know I played for love, but it got me on my knees. Now's the time to reap what I've sown. Your words echoing in every single bone.
The next day we move our attention round to the other side of the building to build the third window buff. The third window is made by the same manufacturers as the first two windows on the front, so we'll be using the same system to create the extended window frame. One of the reasons I wanted to wait to have my windows on site before creating my window and door openings is because of this process. It would be logistically difficult and time expensive to adjust the size of these window openings. So by waiting to have the actual windows here to measure against, I'm confident in not having to make any adjustments to the opening size. With the 3 windows complete, I start the frame extension on the 2 doorways we have. Like I mentioned earlier, the doors and windows come from different manufacturers, so the frame extension on the door is only 20mm instead of the 40mm we did on the windows. I'll only be installing 1 layer of the 20mm thick pine framing. I'll be using liquid nails glue and screws like I did with the windows. One of the reasons why I use a bead of liquid nails is to help eliminate any micro drafts or air gaps that can penetrate our building.
Now everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it. Everything that has been don't matter no more. We've burned it.
With all the timber elements complete for the window and door buffs, I move on to installing the waterproof flashing elements. The first step will be to add silver tape to the sides of our window extension. This will stop any moisture in the rain screen cavity from penetrating the window frame. This silver tape is not always easy to apply due to how sticky it is. Once the paper backing is removed, it has a tendency to stick to itself, so you need to have a strategy in mind when applying it. When I'm installing this kind of tape to an inside corner, I work in small pieces about 300mm long so it's manageable. The silver tape flashing comes in different widths. Here I'm using 50mm wide tape, as it's just wide enough to create a small overlap on our membrane and the front of our window buff. By working with small manageable pieces, I carefully stick the edge of the tape to the front of the window buff and then roll it onto the side of the frame, ensuring I have a slight overlap on our membrane. When the flashing process is complete, we don't want any gaps in our materials, so we create slight overlaps between one edge of the tape and the next. This will ensure no moisture can penetrate the wood in our frame. Once I complete the bottom section of this frame, I move on to the sides and continue to work my way around until the whole frame's covered with silver tape on its edge.
Come closer, dance for me. Easy, tiger, easy, let your hair down. Come closer, let me see all your million faces and all your million mistakes. You don't need to hide.
The next step in our window flashing process is to add tape to the front and inside edges of the window buff frame extension. This creates a waterproof gasket between the timber elements of our wall and the aluminium window frames. To apply this purpose-made stretchable window flashing, I take measurements of the window frame and pre-cut pieces so it's easier to manage while sticking it onto the frame. These flashing tapes come with a waxed paper backing. This helps me keep control of where the tape sticks. Once this tape sticks to a surface, it's very difficult to reposition it. So my process for getting the tape to stick in the correct position the first time is to peel a small piece of the backing to expose a little bit of the sticky part of the tape and get it started on the edge of the window frame. I can then remove more of the wax paper backing as I stick the tape down, working left to right in small sections. When the front edge of the bottom of the window frame buff is covered, I move on to the inside corner. Adding this extremely sticky tape to an inside corner can be tricky, so I use a system of folding the tape in half, then removing the backing from only half the tape. I then use a paint scraper to help position the tape into the inside corner. Once half the tape's stuck in place, I can remove the backing from the other half and stick the tape to the rest of the inside corner. This inside bottom corner of the window frame is the most likely place for rot to occur if the flashing isn't installed properly. This purpose-made stretchable flashing tape was designed to help solve the problem of this inside corner. It allows you to stick the tape to the inside of the frame and then stretch it to the outside of the frame. This creates a waterproof seal in this difficult corner area. When I've completed the flashing for the bottom corners, I continue to install the flashing tape around the rest of the frame. One of the important parts of installing any flashing is to use the shingle principle, and shingling means you always have the higher layer overlapping the bottom layer. This helps stop water infiltrating the overlaps of the tape. Flashing elements complete on these two window buffs, the last step in the process is to add a piece of membrane on the top of the wall above the windows. I left this piece of membrane out when we covered the walls earlier, as it's more practical to put it on now. This is part of the shingling process of applying the top piece on last to keep the materials overlapping so the water can flow over the top of them. After this final piece of membrane is stapled in place, these frames are ready for window installation.
Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true, no matter where I go, I'm coming home to you.
With the flashing complete on these two windows, I move my way around the building, flashing out the rest of the openings. I'm using a similar process to flash the door frame out, with the main difference being there's no sill on the bottom like the windows. The doors we're installing come with their own threshold built in, which looks after the water being channeled out of the bottom of the door frame.
I have seen many places where the beauty never ends. Different cities, friendly faces, and perhaps I'm going here than I can bear. Ooh. Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true, no matter where I go, I'm coming home to you. Been walking down the street so many times, my feet know every brick and stone. Could wear a blindfold, no matter what I do, I'm coming home to you.
Finishing off the top of this window slightly differently than the others, as there's no eave on this side of our building. I've added a bead of Sikaflex to help stop any water or moisture penetrating through the inside top corner of this window frame. Here you can see how I've created an overlap in the membrane so it can channel water out of our rain cavity and into the front face of the window when it's installed. With the window and door buffs complete, I move on to installing the foil board, which will be the insulation of our building. I'll be installing it over the breathable membrane to create an almost unbroken blanket of insulation around the walls and roof. I'll be using 2 different thicknesses of foil board, 25mm thick for the roof and 15mm for the walls. The foil board product comes in a standard sheeting size of 2.4 by 1.2 meters. This will enable me to have the seams of the foil board laid directly on the studs of our frame, which later on will be covered with our battens. After doing a cutout for the pet door, I can go through the process of attaching this first sheet to our wall. To avoid any unnecessary perforations in our insulation, I'm using a system of taping the edges to the membrane and then stapling the tape in place. By applying foil tape along the joins of the foil board, I'll be able to ensure an air and watertight seal between each sheet. It also gives me a way of stapling the foil board to the OSB under the membrane. I then use small pieces of foil tape to cover all the staple holes to ensure no moisture can leak into the walls. I then continue the process around the sides of the foil board, and in this case that involves sealing around the pet door.
Feel like the air and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memory.
Another reason why I'm applying tape to all the edges of the foil board is that the polystyrene in the foil board will shrink a little bit over time. This creates small gaps between the sheets, which will compromise the insulation membrane. So by adding foil tape on the edges, it'll help mitigate the small gaps that are created later as it ages.
Feel like the air and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memory.
One of the important passive house design elements we're using in our studio is to install insulation over the outside of our frame to help create an unbroken thermal barrier. The more common way of insulating walls by adding the insulation between the timber studs on the inside of the wall has a couple of disadvantages. The timber framing in the walls that the insulation is laid in between becomes the weak point in the thermal barrier, resulting in heat being allowed to leak through the timber elements of the wall. So by installing solid insulation sheets on the outside frame of the wall, it creates a more consistent and efficient thermal barrier, which is why this system is used more often in modern homes these days. I'm fitting the last pieces in this wall extra tight to help account for the shrinkage in the material later on. By cutting the foam board about 3 to 5mm larger than the gap, I can get a tight fit without snapping or damaging the foam board. Another important aspect of installing the foam board is to make sure I get a tight fit around the window buffs.
Cutting grass and chopping wood can be romantic. Sipping coffee under the apple tree is gentlemanly. Well, you're a good man, quite the best man, a real fine man. When the wind blows and the windows are closing, you let the world know that what has been has been. There's no use in looking back, going back, wishing back.
Because the foil board has a membrane of aluminium foil on both sides of it, I prefer using a wood saw to make an accurate and controlled cut. especially when creating a long, thin piece like this one to fill out the top of the wall. Because this piece is wedge-shaped to account for the rake in our roof, I'm cutting it in 2 stages. After checking that the angle is correct in this small triangular piece, I scribe the end off it, then trim it and return it in place. This way I can get the tight fit we're trying to achieve to help avoid any gaps that'll happen later when it slightly shrinks. I then complete the process by adding foil tape along the seam. Here I'm using multiple pieces of foil tape, as it can be difficult to manage due to its extreme stickiness. After rubbing the foil smooth along the seam, I take measurements for the final piece to complete this wall, then transfer the numbers to the sheet of foil board in preparation for cutting it out. I'm using an offcut of OSB that matches the angle of our roof rake as a template. By aligning the square side of the template to the square edge of the foil board, I can accurately transfer the angle of the roof to our material. When I'm satisfied the template's sitting completely parallel to the foil board, I mark it out with a pen and then cut it with my timber saw.
You master how to simplify. You turn rain into a blue sky. Oh, when the wind blows and the windows are closing, you let the world know that what has been, and there's no use looking back, going back, wishing back.
As I complete the insulation for the final wall of the studio, I continue to use a layout pattern of covering the bottom half of the wall first and then working my way up to the top of the wall. Once I'm satisfied the piece is fitting properly, I secure it in place by taping the 4 corners with small pieces of silver tape. One of the advantages of this particular product is it has 100mm grid lines laid out on it, which makes it easy to transfer measurements from the wall to the material and make an accurate straight cut. After installing all the pieces for the next layer of foil board along the wall, we come to the top section of the wall, which is going to require a different approach than the other walls we've done. I'm installing a piece of timber quad along the top of the wall. It's 15mm thick, which is the same as the foil board thickness. This will help create a strong and secure foundation for the materials we'll be adding later. To fix it in place, I'm using 40mm long galvanized bullet head nails. I use a scrap piece of timber to keep it in line with the roof plane and add a nail every 300mm.
Hey darling, you know we're gonna have a really good time, driving in the middle of the night when the stars are bright. Pack our bags and get in that car, leave a little note and we'll drive real far.
Another advantage of installing insulation on the outside of your frame like this is it pushes the condensation point to the outside of our membrane. This helps to keep the inside wall cavity dry and help avoid moisture and mold issues in the life of the building. The battens we'll be adding over the top of the foil board will create an air cavity for moisture to collect and drain out from the bottom of the wall. This is all part of the passive house design techniques that help keep the structure dry, warm, and energy efficient. The next step in the construction of our walls is to add timber battens over the foil board insulation. The 25mm thick battens create an air gap between the insulation and the outside cladding of the wall, which in our case will be cement sheet. The battens are laid in alignment with the studs of the wall, with the vertical studs 600 on centre and the horizontal studs 1200. A couple of weeks ago I started the preparation of the material we'll be using for our studs. They're 50mm wide with drainage channels for the horizontal battens. The first step in the manufacture of our battens was to cut drainage channels in the 150mm treated pine stock planking. We did this by making shallow 45-degree cuts across the planking in 100mm intervals. After making cuts all the way along the length of the plank, we turn the plank around and cut in the other direction. This creates a V-shaped notch for the draining of the condensation that'll collect inside the cavity of the rain screen. The next step is to turn the stock 150mm wide planking into 50mm battens. For efficiency, I'm clamping 2 planks together and making 2 50mm rips with my saw to create 3 battens out of each plank.
Can I tell you what's been on my mind? Sick and tired of the 9 to 5 in the city light. Hey, darling, we could get out of town, see the beautiful world around, wanna see it now.
The next step in the preparation of our battens is to sand and seal them. I'm sanding the edges to remove any sharp corners that might damage our insulation when we're installing it. The foil board is clad in a thin sheet of aluminium foil which can tear easily and compromise the membrane, so by sanding all the edges we should avoid this problem. For efficiency, I'm clamping 3 battens together to apply our sealant, starting with painting out the notches we cut earlier. This is where the condensation will be draining through on the horizontal battens, so I want to make sure it's sealed effectively so it doesn't absorb any moisture in the process. After liberally applying 2 coats of the lanolin timber sealer, I let them dry for a couple of days before installing them on the wall. I'll be attaching the vertical corner battens first. They'll be pre-assembled on the bench before I install them on the corner of our building. After getting a measurement, I select one of the straighter pieces of batten, cut it and double check it for fit before starting the process of assembling the corner unit. I'm using clamps to hold the 2 pieces together. This enables me to get a tight and accurate fit, while I pre-drill and install 8-gauge screws along the entire batten. I'm attaching the corner battens to the wall with 75mm long 14-gauge screws. The screw heads need to end up flush with the surface of the batten to avoid any problems later when we're adding the final cladding to the wall. To achieve this, I need to pre-drill the holes with 2 different sized drill bits. The first hole is pre-drilled with a large gauge drill bit to create a hole for the screw head, and then pre-drilled with a narrower gauge drill bit for the shaft of the screw. I'm adding screws in 400mm intervals to create a secure attachment to the frame underneath our insulation. The next batten I'm installing is a horizontal one that'll lie along the bottom of our wall. These horizontal battens have the drainage slots we prepared earlier. By temporarily setting it hard up against one of our installed corner pieces, I can get an accurate cut mark, trim it on the saw, and then return it in place for installation. I'm attaching it to the wall with 75mm 14-gauge screws like we did with our corner pieces. I'm drilling my pilot holes on a slight angle to make sure the screw catches the center of the bottom plate on the inside of the wall. I can then remove the 10mm packers that are creating a drainage gap for the bottom of the wall system. To install the batten that runs along the top of our wall, I use a clamp to hold it in place whilst I scribe my cut mark. Although it requires some extra work to scribe a long piece of material like this in place, it's worth it as I end up with a highly accurate cut point. I secure this piece the same way we did the bottom batten. You may have noticed this piece doesn't have any drainage slots in it. That's because being at the very top of the rain screen wall, it doesn't need drainage holes like the ones in the middle and the lower part of the wall do. With the 4 outside edges of our wall battened, we move on to filling out the middle of the wall with battens that match the inside of our wall frame. I start the process by adding marks on our foil board at 600 on centre. I've cut my vertical battens slightly oversized to get a really tight fit. It also helps them stay in place before we add the fixings.
One way, gonna lay down, be still, won't waste another tear. Wait till it disappears.
Because the vertical battens align with the exposed roof rafters, I start the fixing process on the top of these battens and double check them with my level and then fix them off on the bottom.
Can I go to sleep, buried in my chair? The only thing that's left.
To fix these vertical battens to our wall, I'm using a 65mm 10 gauge stainless steel decking screw. By using a smaller gauge screw on these vertical battens, I've got less chance of running into a screw head when I'm installing the exterior cement sheet cladding. With our vertical battens secured to the wall, I start the process of installing the horizontal battens by running a string line across the wall. This helps me create accurate pencil marks to keep the horizontal battens aligned with the inside blocks of our timber framed wall. With this section complete, I move along the wall and start adding battens hard up against our window buff.
If you have love, you wanna give me some, and I will wait for someone else to come. Oh, it's sad, but it feels right. Are we just hallucinating now? This is the final act, just take a bow. While it all falls apart, guess you can't win them all. Oh no.
With the battens complete on the right-hand side of this first wall, I continue the process of adding battens around the windows. Each wall needs a horizontal batten at 1200 on centre. This helps create a joining point for the cement sheet we'll be adding later. I'm pre-drilling my holes and adding 65mm 10 gauge stainless steel decking screws to hold them in place.
Over and over, injustice to injury. This is a part of it all. Could you hike back to it, fight with it, sit with it? This is a part of it all.
I then add small pieces of batten to the top and bottom of the windows that mirror the 600 on centre stud wall layout. I cut all my battens slightly oversized to help create a tight fit. Here I'm adding a 1.5mm packer to help the small batten fit flush with the others. The foam board underneath our battens is made out of polystyrene with foil on both sides, so it's quite a soft material. That's why it's sometimes necessary to add a packer under the batten to help keep the outside of the batten plane flush, which will be essential for later on when we're adding the cement sheet on top. After adding the 65mm stainless steel screws to the battens underneath the window, I move on to adding small battens above the window.
There's no use in trying, and even if you could, it wouldn't come out like it should. This stubborn kudzu just covers these words. Could you listen to somebody else? Will you only drink from the thoughts of yourself? Are you under the canopy spell? You dig in your heels and spread the Pack up the drive a bit this is a part of it all. Over and over, injustice to injury, this is a part of it all. Could you hike back to it, fight with it, sit with it, this is a part of it all.
The first step to adding battens on this wall is to add the corner pieces. I've pre-assembled the corner pieces by joining two battens together like I did earlier on the first wall. The four corner pieces of the studio must be completely plumb and square. So I take extra time and double check with my level before fixing it in place. I'm using 75mm long 14 gauge screws. Because of the soft nature of the polystyrene foam board, this requires going back and forth with the screw to set the batten flat and not add too much compression to the foam board underneath.
Daydreamer, kidnap me. Take me back, all the way back to them days. Running around in a gown and a crown, barefoot.
To install our last corner on the studio, I'm using my large clamp to help hold it completely straight whilst we fix it in place with the 75mm screws. Once the corner piece is secured at the top and the bottom, I fill out the rest of the corner with screws every 400mm. Here you can see how I've offset the screw pattern around the corner to create a really solid connection to the framing underneath our foam board. With the two corners secured, I move on to adding battens to the rest of the wall, starting with the doorway.
So offshore, playful and free, without a care in the world. I was one rich little girl, daydreamer, kidnap me. Take me back, all the way back to them days. Running around in a gown and a crown, barefoot.
With all the vertical battens in place for this wall, I start adding the horizontal battens that have drainage slots cut in them that we prepared earlier. I'm installing these battens with a 10mm gap under the window buff. This 10mm air gap will help avoid moisture being trapped under the windowsill. The wall on this side of the studio doesn't have any eaves to protect it from the rain, so I'm taking extra steps to make sure the window can drain properly. By pre-drilling my pilot holes on a 45-degree angle, I'm able to fix these horizontal battens into the vertical studs on the inside of the wall.
One big smile across my face. We used to dance our way to church on Sundays. Mama set the pace. Daydreamer, kidnap me. Take me back, all the way back to them days. Running around in a gown and a crown, barefoot.
Because this is the eaveless side of our studio, I'm leaving a space at the top of these vertical battens for a wider batten I'll be installing later after I've added the insulation elements to the roof. The rain screen air gap needs an uninterrupted connection between this wall and the low side of our roof. Because of the design of our studio, each wall frame configuration is unique. With this wall, I didn't use a 600 on center layout for the vertical studs. It was more important to place the studs under the bridging rafters in our roof. With the batten installation complete on 3 of our walls, I move on to the 4th and final wall.
Standing underneath the lights, look into each other's eyes. Tired snowflakes are coming down, collapse into water when they hit the ground. I hear the sound of empty streets. Yesterday has gone to sleep, so all that's left it's you and me. I can promise you're the only thing I see. Hold my hand and hear the words I say. Close your eyes and let us fade away. Build a secret place for you and me. Let our minds be caught up in a dream.
We've now completed all the sub-sheeting materials of our walls, including the OSB bracing sheeting, the membrane, oil board insulation, and then these treated timber battens that create the rain screen for the cement board that'll be coming on later. We can now finish off this bug screen that we installed earlier, just to stop insects from getting through our water channels in this treated timber batten material. We'll just be wrapping it up and stapling it and trimming it off, and then when the cement board goes over the top, it creates a nice bug-proof water channel underneath here.
Quiet voices in the night. Time is running out of sight. A lonely wind is passing by. Tries to carry all the whispers that it finds. The walls are listening when we talk, making echoes as we walk. There's no one left but you and me. It's like a made-up place that only we can see.
Once the fly mesh is secured with the staples, I cut the excess off flush with the bottom batten. It's important to trim the excess fly mesh so it doesn't get in the way when we're adding the cement sheets later. Adding a barrier for insects is an essential part of the design of a rain screen. Because we're creating a permanent void in the wall, it could easily get infiltrated with insects if there wasn't some kind of screen to stop them getting in. Here you can see how the 10mm gap underneath the bottom batten will allow water to drain out but stop insects getting in. With the principal rain screen elements complete on the walls, we're going to move our attention back to the roof. I need to install one last piece of roof frame. It's a fascia that sits on the low side of our open area of the roof. Once this is in place, we'll be able to put the marine ply ceiling panels on. To prepare our fascia, I need to do a small checkout at one end so it'll fit over the post we already have in place. I make 2 cuts with my saw to set the outside edges of the checkout, and then do multiple slices at 5 to 10mm apart. This makes it easy to remove the rest of the material with my chisel.
Yesterday there was sun and there was rain, beauty in the mundane. And as the light startled our eyes, we let go of disguise.
I finish off the checkout with my sander, then check it in place to see how well it's fitting.
There's something in the air and a sparkly shimmer on our skin, restoring everything within. Oh, dreamy, breezy we go, easy, easy on our tiptoes, undercover agents of the other, beyond gravel, beyond all.
It's important that this fascia matches the roof plane perfectly, so when I add the plywood it'll sit completely flat. Once I'm satisfied with the fit, I remove the beam so I can do some touch-up painting. It's much easier to pre-paint it before installation than to try and touch it up once it's connected to the roof rafters. Once the paint's dry, I return the beam to its position, clamp it in place, and fix it off with the heavy 14-gauge timber screws we've been using throughout the framing process.
Dreamy, breezy we go, easy, easy beyond a bigger scale the world inhales as we go. I wouldn't want it any other way. Dreamy, breezy, we go.
Yesterday I started the sheeting process of the roof with our marine ply, but I got my clients to help prepare off-site by painting polyurethane on both sides. This way we'll get the nice natural timber look from underneath when we look up at the ceiling. We've been having severe weather conditions during springtime in this location, so we've got a small window of opportunity of good weather today and over the next couple of days to get all the roof elements on so we can waterproof our site with the installation of the doors and windows. So today we're going to try and finish sheeting all the plywood. Then we'll be adding our membrane, insulation, battens, and then finally corrugated iron.
It's always important to have an attitude of safety on a construction site, but especially when working on a roof. Here you can see how I have a support ramp to safely and effectively get the plywood sheets up onto the rafters. I'm using a standard layout by offsetting each sheet by half from one row to the next. Once the plywood sheet is roughly in the correct position, I double check the outside edges that it's lying correctly on the rafters. I use my set square to make sure the sheet is laying square on the roof frame before securing it with a nail on each corner.
Turn around and show your face. Let me see parts of you. Oh my, our bodies interlace, slow and easy.
I then mark out pencil lines aligning with our roof rafters to nail out the center of the plywood. I'm using a nail gun like I did with the wall sheeting to help speed up this process.
I can hear you within the silence. We will dance away the gloomy days right here.
I'm using slightly shorter 40mm long nails for the outside edge of the sheets that run along the front of the awning. The plywood sheeting isn't wide enough to reach the outside edge of our roof, so I'll be adding a thin strip of plywood to fill this gap later. For safety reasons, I bring one sheet of plywood up at a time, fix it in place before bringing the next sheet up for installation.
Stay close when it rains. Let me keep parts of you. Hand in hand is how we sleep every night. And I will watch you, breath after breath, hold on. So beautiful. And if you fall, I will catch you.
Here I'm repositioning my movable plywood roof hatch. I built this earlier in the process for creating a temporary platform when I'm working on the roof rafters. It gives me safe and easy access to all four sides of the plywood panel without the risk of accidentally falling through the open rafters. In the original design of our studio, we were going to be using OSB for this sheeting like we did for the walls. But because my client made the decision to have exposed roof rafters, we chose marine ply so we could have a clear polyurethane finish and a much better looking ceiling.
And I can reach you from a distance. I can, so beautiful.
We'll complete all the other elements for our roof, including running electrical wires for the lighting system and completing the edge of the plywood ceiling. Then adding the membrane, insulation, battens, and finally the corrugated iron sheeting for the roof. The corrugated iron is the final layer of 6 that make up the roof of our studio. Under the iron, the treated timber battens create an air gap for condensation to collect and evaporate out of the roof. The battens are laid on top of 25mm thick foil board insulation that creates the thermal barrier that'll keep it warm in winter and cool in summer. The breathable membrane waterproofs the marine ply panels that create the ceiling and adds shear strength to the roof rafters. Before covering the marine ply with the other elements of the roof, I want to run some electric cabling for the lighting of our studio. Our electrician has started the process of running electric cables through the walls of our studio in the standard way, but because we have exposed roof rafters and a plywood ceiling, we're going to run the cables through the top of the wall and on the outside skin of our ceiling to keep the cabling invisible on the inside of our exposed roof rafters and plywood paneling. Here I'm helping the electrician run cables across the top of our plywood ceiling through holes we drilled through the roof rafters to keep the wiring invisible on the inside.
Every step, every breath for you. My head's up over the clouds for you. If there's a valley, I'd build a bridge so that you could get by. Or I'd grow wings so we could fly. Daydreaming is my new middle name. This is not a game for me.
Here the electrician's drilling a hole through the top of the wall plate so we can feed the main power source cable up onto the roof and back down into the corner where the switch will be for the lights. With the last of the cable run through the top of the wall, I start the process of fixing the cables in place by hammering cable clips onto our plywood ceiling panels. I always use a licensed electrician to supervise the wiring of my projects, which results in a safer and more reliable electrical installation.
Daydreaming is my new middle name. This is not a game for me.
With the electrical cables in place, we can now complete the plywood element of our ceiling by adding the strips of plywood on the outer edges of our roof. Earlier I took measurements of the gap in our roof so I could manufacture some plywood strips on the ground where it's safer and more efficient. After marking my material out with a straight edge, I find it easier to cut plywood like this close to the ground. This way I can walk along the side of the plywood sheet as I'm cutting it and keep good control of the saw.
Peel off a layer and breathe. Lift up your head and breathe. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memory.
By laying the marine ply strip parallel to its final position, I can easily mark the cutouts so it'll fit around the cables we installed.
Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you leave.
With the strip on the low side of the roof complete, I move my attention to the high side of our roof where we have to add another plywood strip. This one goes on much easier as I don't have any cables to cut around. This completes the marine ply paneling for our ceiling, which is the first of 6 layers of material we'll be adding to complete our roof. There was rain predicted overnight, so we covered the roof with a large tarpaulin. I wanted to keep the marine ply ceiling dry as possible so we don't trap any moisture with the extra layers of material we'll be adding over the next few days. I temporarily screwed down treated timber battens that we'll be using later in our roof construction so the wind wouldn't blow the tarpaulin off during the night.
Give me tears so I can cry. Give me hope so I don't die. Give me tears so I can cry.
I'm using the same same breathable membrane material we used on the walls. Because we'll end up with a second layer of waterproofing with the foil board insulation, it's important that this membrane is breathable so it doesn't trap moisture under the insulation. I'm using lengths of treated timber batten to hold it in place whilst I tack it into position. I'm only tacking the membrane on the edges so I don't make any unnecessary penetration points that water could leak through later.
Give me tears so I can cry. And give me heart so I don't die. Give me tears so I can cry. And give me heart so I don't die.
With the first piece secured, I start rolling out the second piece. Because the membrane roll is 2.7 meters wide, we can cover the roof in 2 passes with a 200mm overlap. After getting the edge of the membrane secured on the side of the roof, it's important to roll it out square and flat without any creases in the membrane. I do it in manageable sections using the battens to help hold it down so the wind doesn't get underneath it. When I get to the end of the roof, I cut it off the roll and tack it in place, making sure it's flat and wrinkle-free. The last step in the installation of the membrane on our roof is to tape the 2 pieces together along the centre of the roof. I also add tape over the tacks around the edges, so we have a waterproof membrane covering the entire roof surface. The second layer of our 6 elements we're adding to our roof will be the 25mm thick foil board insulation. This will help keep our studio warm in winter and cool in summer. Installing the foam board has similar difficulties to the installation of the membrane, managing ultralight materials in windy conditions. To help hold the foil board in place, I'm using a combination of my battens and an off-cut of marine ply. This way I can kneel on the fragile foil board whilst taping it in place without crushing it. I'm using the same system to install the foil board on the roof as we did for the installation of the walls. I use foil tape to lock in each corner of the sheet and then use more foil tape along the seams to give it a more stable contact with the roof.
Mud on your boots tell the story of where you've been. Travel, beat up, warning with settled soul. Trust your gut, you have earned at least that. Age has proven to be kind.
With the first row of foil boards secured in place with the silver tape, I install a batten on the leading edge of the roof. This will help secure and hold them in place overnight so the wind won't blow them off by the morning. I'm using 100mm 14 gauge screws to fix the batten in place because it has to go through 27mm of batten, 25mm of foil board, 6mm of plywood and then anchor into the rafter. The next morning I spend a bit of time drying the condensation off the roof in an attempt to not trap any unnecessary moisture under our foil board insulation. The next piece of foil board we're installing is going to require some customization for the electric cabling we ran over the top of the plywood for the lighting in our studio. I need to cut a channel out of the foil board that matches the electric cabling. This will allow the foil board to sit flat on our roof. I'm using my set square to transpose measurements onto the foil board that match the curved layout of our cabling. This will ensure an accurate cut.
Love heart is not in vain. Scar earned by the good fight. Weathered skin from the sun. We're proud you have lived well.
With the channel clearly marked with black felt pen, I set up an improvised cutting bench so I can cut the foil board without damaging the membrane. I'm using a timber saw to make the cut, as the foil board's really soft and the trick is to cut it without breaking it. When I'm satisfied the first piece fits around the cables, I tape it in place and then add the second piece. Here you can see how we've left a channel for the cabling so we don't create a lump in our roof. As I continue adding foil board to the roof, the cutout for the cabling becomes much simpler because it's set in a straight line at this point. I'm filling out the void we created for the wiring with a thinned out piece of foil board, then taping it over with silver tape so it'll stay in place and remain waterproof under the corrugated iron. There's a couple of reasons why I've chosen to install foil board on our studio in this way. Solid polystyrene foil-backed battens are waterproof and won't retain any moisture. This helps avoid any mold or mildew being trapped in our walls or ceiling. And by installing it on top of the rafters and plywood bracing, I can achieve an unbroken thermal blanket of insulation, which avoids thermal bridging, where a lot of the R rating is lost in an insulation system. As I'm coming close to finishing the installation of the foil board on our roof, here I'm using an alternative way to create a channel for the cable that's on the plywood so we don't end up with a bump in the foil, which would interfere with our batten and corrugated iron we'll be adding on top.
But there's some words that I just wanna hear you say, to put it all straight before this night turns into day, and then I'm on my way. Yes, I'm on my way. A bit naive and so eager to please. You know I played for love, but it got me on my knees. Now's the time to reap what I've sown. Your words echoing in every single bone. So far out at sea, there's no cure for what you're telling me, and soon I'm on my way.
With the 25mm foil board insulation secured, the next step is to install our 27mm thick treated timber battens. This creates the air gap under the corrugated iron where condensation will form and evaporate out. The battens align directly with the rafters, providing an anchor point for the screws in the roof. To ensure I'm installing the battens directly on top of the rafters, I'm using a story stick I prepared earlier that has the exact layout of the rafters clearly marked on it. When the batten's aligned with the mark on the story stick, I screw it in place and then move the story stick to the next fixing point, double checking that it's aligned with the top of the roof to keep the layout accurate and parallel. To make things easier for myself, I pre-drilled all the holes in the battens on the ground, following our 600 on center layout. The story stick template matches the roof width exactly, so I can align it from either end. I'm using the same process to fix the screws in on the roof as we did with our wall battens. After drilling a pilot hole, I work the screw back and forth so as not to put too much compression on the foil board.
You said, let me tell you everything I've seen, friends I've made, and then you tell me how you've been. Look a little closer, it's been quite some time. You gotta let me know if I'm out of line.
With all the roof battens in place, it's time to install the segue point between the low side of the roof and the back wall. I've designed it so the condensation gap in the wall and the roof connect together at the low side of the roof through the drainage slots we cut earlier in our battens. All the battens we've used so far are 50mm wide. This last specialised batten is 150mm. This is to provide a sturdy anchor point for the guttering we'll be adding towards the end of the project. The 150mm wide batten has the same drainage slot pattern as the 50mm battens. This way the drainage channels will align perfectly, allowing an uninterrupted airflow between the roof and the wall. I'm attaching this batten the same way we've attached all the battens, using heavy 14 gauge timber screws. Here you can see how we've created a strong and crisp corner for the transition between the low side of our roof and the back wall. This is a really important part of the eaveless design of this side of the studio. The final step in completing the battens for the roof is to add pieces along the side of the roof in between the 50mm battens. I'm using the same thickness of batten material, but these pieces will be 150mm wide. I pre-cut all the pieces on the ground and pre-drill all the holes in preparation for installation on the roof. An important part of prepping my material is cutting out any large knots, as they create weakness in the planking.
Spending Sunday at the gym, trying to fit in. Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of taking, not enough time, A whole lot of sweat, trophy wide, trophy wide. The clock keeps ticking, still running out of time.
That completes the treated timber battening for our roof. The next stage will be preparing the corrugated iron for installation. I was able to order the zinc-coated sheets cut to the correct size straight from the supplier. So the only preparation I need to do is to pre-drill my holes for the screws that'll be holding the corrugated iron onto the battens and rafters. Having them laid flat on this pallet will create a good temporary workbench for this process. To mark out our screw holes, I'm using the same story stick we used to align the battens with our roof rafters. This is a really accurate way to ensure all our holes end up in complete alignment with the roof rafters, and it's a lot quicker and more efficient than using a tape measure. After transferring the marks on our template story stick to both sides of our corrugated iron, I use a straight edge to make the rest of the marks in the middle of the iron using a permanent felt tip marker. There are a couple of different screw patterns you can use for fixing corrugated iron to your roof. I'm choosing to have a screw in every second corrugation due to the heavy wind loads we have in our area. After adding a piece of timber under our pack of corrugated iron to help stabilize it, I start the process of using a metal punch to create small dents over our black marker. The dents created by the hole punch will help stop the drill from slipping off the top of the crown of the corrugation. This is important to help avoid scratching the zinc off the tin, which will lead to rust later on. I use a brand new bit for the drilling process and take my time and let the drill do the work without adding too much pressure on the drill. Many professional roofers wouldn't bother with this process, as the roof screws are designed to drill their own holes in place. But for people like myself who don't do a lot of roofing, this can avoid a lot of problems later when it comes to the installation of the corrugated iron, and helps you avoid putting any screws in the wrong place. The final step in our preparation is to clean all the swarth off the iron that's left over from the drilling process. The iron filing swarth can rust and cause staining on the roof later, so it's really important to clean up after the drilling process.
9 to 5 was my dad's advice. Don't think twice, I want the luxury life. My beauty can lose it, I'll use it, I'll take what I want.
Here you can see how easy and efficient it is to install the screws through our pre-drilled holes into the battens. The idea is to be quite gentle with the installation of the roofing screws to help avoid distorting the corrugation, which can lead to alignment problems later. Once the first sheet is secured, I bring the next sheet up onto the roof. Each corrugated iron sheet needs to overlap the previous sheet by one corrugation. This is what stops the water getting in the roof. I'm using some offcuts of OSB and framing material to give me support platforms to help avoid damaging the foil board insulation or the corrugated iron as I install it. As each sheet is installed, I double check with my tape measure that the layout is remaining square to the roof.
A whole lot of ticking, running on time. A whole lot of work, trophy wide, like me. Oh.
I'm using a temporary ramp I constructed earlier to help get the tin on the roof without scratching it or injuring ourselves. For safety reasons, I'm only bringing one sheet up on the roof at a time, then fixing it in place before bringing another sheet up. This helps avoid the wind blowing off the corrugated iron, which can be dangerous and also damage our material. I repeat this process until I have all the sheets secured on the roof. I then start the final process of the roof installation by going over each sheet and making sure I have a screw installed in each hole we pre-drilled earlier. I also pre-drill the batten lying underneath the corrugated iron for two reasons. It helps me install the roofing screw more gently into the timber so I don't distort the corrugations, and also helps me double check that I'm not running into a screw head from the batten installation process.
Slow traffic caused me a stress. No panic, I'm just born in a dress. And I know now I'm older, I'm done. I'll do what I want. I'll do what I want. Spending your Sunday, counting the days until I meet the future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of ticking, not enough time, not enough time. A whole lot of sweat, trophy wide, trophy wide. The clock keeps ticking, still running out of time.
With the corrugated iron installed, that completes the sixth layer of elements that make up the passive house design systems for our roof. This is a major step in the construction of our studio as it enables it to dry out, allowing us to install other things like the windows and interior wall sheeting. I'm installing a temporary ramp so we can use a dolly to roll the windows inside the studio. The windows are extremely heavy and hard to lift with two people, so by resting the window on top of the dolly to take the weight, we should be able to move the windows inside quite easily.
Come closer, dance for me. Easy, tiger, easy, let your hair down. Come closer, let me see all your million faces and all your million mistakes.
The next part of the preparation for our window installation is to create platform steps that match the rough opening in our walls. This way we can walk the windows up gently into place and not have to carry the entire weight of the window.
Your eyelids and perfect lips got me rushing pen and I'm so lit. Like lilies you open, fragrance goes to my head, my darling. I get everything that has been, don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it.
I've also added battens on the outside of our rough openings. This is a safety feature to stop them falling out as we get them in place. Professional window installers would be going about this in a different way, using specialised equipment and many more people to do the installation. As there's only Chris and I, we've set up our own customised system to install the windows without damaging them or hurting ourselves. Here you can see how the ramp we constructed earlier helps us roll the window inside the studio. A double glazed window of this size is extremely heavy, so we take our time moving slowly and carefully to avoid causing any damage to the window. Once it's in the upright position, we can carefully walk it up the platform steps we prepared earlier. The rough opening in the wall has been built 20mm higher and 20mm wider than the actual window size. This doesn't give you a lot of wiggle room to fit the window in the opening. So to make it easier for us, the top of these platform timber steps is flush with the bottom of the windowsill, so we can slide the window in carefully. The temporary battens we attach to the outside of the wall stop the window falling out and also help set the plane so the window is sitting in the correct depth of the wall. Once our window is sitting snug up against the outside battens, I add a batten on the inside to ensure the window doesn't fall out of position. After checking from the outside that it's roughly in the correct position, we start the process of the fine-tuning of the window. After double checking with my level that the window's sitting relatively plumb, I add packers in the space between the window frame and the rough opening in the wall. This will help keep the window roughly in the correct position as we make adjustments on the bottom of the window with more packers. Here I'm using my crowbar to help lift the windowsill up so I can insert packers underneath. Once I've filled out the space between the window frame and the wall with the appropriate size packers, I double check it with my level to make sure it's plumb, and then start the process of fixing the window in place with screws. I start the process by drilling a shallow hole with a large drill bit to create a pocket for the screw head, so it'll end up flush with the window reveal. I then drill a pilot hole and install the 10-gauge galvanized screws, leaving them flush with the inside of the reveal so I can cover them later with filler. I also make sure each screw has a packer behind it to ensure we get a solid connection from the window frame into the wall.
Now everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it.
After the window installation is complete, I double check that it's aligned correctly by opening and closing it. We repeat the process on the second identical window and then move on to the large 3-panelled window on the other side of the studio. Our windows and doors arrived about a month ago and we've kept them under our temporary shed to keep them out of the weather. After freeing up the window from all the straps we used to keep it safe from the wind, we carefully place it on the dolly for transport into the studio.
Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true. No matter where I go, I'm coming home to you. Been walking down the street so many times, my feet know every brick and stone. Could wear a blindfold. No matter what I do, I'm coming home to you. And I don't know why, don't know why, don't know why I'm always feeling homesick.
After adding temporary battens on the inside to hold the window in place, I add packers in the 10mm gap between the window and the wall. When I'm satisfied the window's centered in the rough opening, I start the process of securing it by adding our galvanized countersunk screws. I double check the windows in alignment with our extended frame on the outside before continuing with fixing it in place with the screws. The tricky part of this process is getting the packer to hang appropriately over the screw inside the 10mm gap. Here I'm using my crowbar and set square to poke the packer into the appropriate position before securing the screw. After adding 4 screws to each side of the window, we start the process of removing the temporary battens.
I have seen many places where the beauty never ends. Different cities, friendly faces, and perhaps I'm going back.
With our 3 windows secured, we move on to installing the 2 identical doors. They're a lot lighter than the windows, so we don't need the dolly to move them into position. The doors and windows come from different manufacturers and require different installation techniques. The door design is more of an American style, that has a flange which is secured to the outside rough opening frame. After adding some packers under the bottom of the door to make sure that it's level and plumb, I double check that it opens and closes before adding the first screw on the hinge side. I pre-drill the aluminium flange of the window before installing a galvanized flathead screw into the timber frame. I'm adding about half a dozen screws either side of the door to secure it, keeping in mind that later in the process we'll be adding expansion foam into the 10mm gap between the door and window frames and the rough opening. This not only adds a lot of strength to the doors and windows, it seals them to the weather and adds insulation to stop air and cold transferring through the gap. Here you can see how I've added packers behind some of the screws to keep the door frame completely level and plumb. After installing the second identical door in the same way, I always double check that it opens, closes and locks properly. With the first stage of the door and window installation complete, the reason for our temporary shed is now redundant, so it's time to dismantle it.
Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me.
We have a few more steps to complete before the windows and doors are completely weatherproof. Here you can easily see light coming through the 10mm gap between the window frame and the wall. The next step will be to cover this with flashing tape from the outside. I'm applying the purpose-made flashing tape to the bottom of the window first. I'm installing it in small lengths to help manage the extreme stickiness of the product. It's critical to start at the bottom of the window first when you're flashing, so the tape joins overlap in the right direction, which helps stop water being able to seep into any tape overlap points. Once the 10mm gap is completely covered on the bottom of the window, I move up to covering the sides. Here it's possible to use one continual length of flashing tape. This helps avoid any overlaps and opportunities for moisture to leak into the system. Once the flashing tape is secured at the top of the window, I slowly pull the waxed backing paper out as I stick it down the side of the window frame. This helps achieve a really good adhesion between the wall and the window frame without any crinkles or creases. When I reach the bottom of the window with the flashing tape, I make sure it overlaps the piece we added along the sill first. Then cut off the excess and move on to the other side of the window.
Cutting grass and chopping wood can be romantic. Sipping coffee under the apple tree is gentlemanly. Well, you're a good man, quite the best man, a real fine man. When the wind blows and the windows are closing, you let the world know that what has been has been. And there's no use in looking back, going back, wishing back.
After marking out the membrane, I'm cutting it off so it fits just above the top of the window flange. This will help direct any moisture that forms in the top of the window outside the wall into our rain screen cavity. Once I've completed the cut, I attach the membrane to the top of the window flange with our flashing tape, using smaller pieces so it's manageable. The purpose-made flashing tape is extremely sticky, so by doing it in small pieces, it stops it sticking in the wrong place. The final step in the flashing process is to drill 2 small holes at the bottom of the sill. These holes will help any moisture that's trapped under the sill drain out into the rain screen cavity.
There's no use in looking back, going back, wishing back.
flashing complete on the windows and doors, we move on to the cement sheet cladding that's the final layer on the outside of our walls. The cement sheet we're using is 1200mm wide and matches our 600mm on centre stud layout in the walls. The material's quite heavy, so to make it easy for us, I've set up a temporary timber platform. This helps take the weight of the sheet so we can make adjustments to get it in the correct position. I then position it so the edge of the sheet lays halfway across the battens that match the stud layout in our wall. I use packers to get the sheet completely plumb with the wall before securing it with a galvanised nail. When I'm satisfied with the position, I fill out the sheet with nails every 300mm.
Oh, it's sad, but it feels right. Are we just hallucinating now? This is the final I just take a bow. While it all falls apart, guess you can't win them all. Oh no.
Sheeting the section between the two windows is going to require some additional attention. I've cut a piece of scrap timber to help me calculate the size of the packers I'll need to add to bring this piece of sheeting up to the correct wall plane. Part of the preparation for this is marking out where I'll be placing the packers, as they need to fall directly under the nails we'll be adding later. With the sheeting complete on the right hand side of the wall, I'm moving the temporary bench that assists me in setting the sheets at the correct height and also provides a clean platform for the packers and tape I'll be using in the next step. It's worth spending some time to get this temporary bench at the correct height. By removing some gravel, I can set the bench about 5 to 10mm lower than the finished height of the cement sheet. This gives me enough wiggle room to add packers under the cement sheet so I can get it plumb to the wall. Once the bench is at the correct height, I start preparations for sticking the packers onto the battens to help correct the slight defect in our wall. I'm using small pieces of the purpose-made flashing tape to hold the packers in the correct position on the battens. I then use my scrap piece of timber to help make a measurement of what size packers I need to add to keep the wall plane true to the edge of the window. By using a combination of 1.5mm to 3mm packers, I can make up the slight defect we have in the wall here. The thickness of the timber wall studs and battens isn't perfect, so by adding packers in this way we can correct any variations in our wall plane.
Breaking feedback, unless I'm gonna stay right here, stay until it disappears.
Prepared with 1.5 and 3mm packers, my next step is to cut the thin piece of cement sheet that'll fit in between our windows. After penciling out the marks, I clamp a piece of aluminium angle to the cement sheet to hold it in place whilst I cut it with a scoring knife. I'm using a purpose-made tool that's designed to scratch a trench into the cement sheet. The process to cut cement sheet is a score and snap method. Once I've scored the line on the material, I use my aluminium angle as a leverage point under the score mark, then tap along the line with my rubber hammer. This helps crack the material in a perfectly straight line. I then mark and score the next cut. This time I'm using a different method to snap the piece of cement sheet by using the edge of our temporary bench. The next step is to mark the nail holes out with our story stick. This will ensure that the nails line up with the packers we added to the battens earlier.
Can I go to sleep, buried in my chest? The only thing
larger vertical pieces installed on the wall, I'm now working on smaller horizontal pieces above and below the window. I'm doing a dry test fit to make sure it lines up before I add any glue. You'll notice I have packers taped about every 200mm along the bottom of the sill. This is to help water drain out of the window system into the rain screen. When I apply the glue, I make sure I leave gaps in between the 3mm packers. This will ensure a drainage channel directly under the sill. After I've applied the glue, I gently return the cement sheet to its correct position and fix it in place with a combination of screws and nails. I'm using countersunk stainless steel decking screws for the edge closest to the window. I install a screw over each packer that's lying behind the cement sheet. This allows me more control than using nails for the section that's over the drainage channels.
As a young girl, it feels we're mine. We played hide and seek for hours, raised our shadows among the pines. So offshore, playful and free, without a care in the world. I was one rich little girl, daydreamer, kidnap me. Take me back, all the way back to them days, running around in a gown and a crown, barefoot.
With the cement sheet complete on this wall, I move around to the side of our studio to sheet the wall that has the pet door opening. Because of the raked roof on this wall, I'll be doing a slightly different configuration of the cement sheeting. The pet door is the only opening on this wall, so I prepare it in the same way as we did the previous windows, but on a smaller scale. We're sheeting this wall in two halves. After the bottom half of the wall's covered with cement sheet, we move on to sheeting the top half. I attach a temporary batten to the wall to create a ledge to assist in this process. When all the sheets are in place on this wall, I add Sikaflex around the pet door opening to create a waterproof seal. Before we start installing the cement sheet to this side of the studio, I have some work to do on the door frame. I'm adding a timber frame extension similar to the window buffs, but because the door frames come from a different manufacturer, it requires a slightly different approach. I'm placing packers over the flange of the door, so when I add the timber over the top, it'll come up to the same thickness as our battens on the wall. This will enable the cement sheet to sit flat all the way up to the edge of the door. Here I'm trying different sized packers, then double checking with my set square to see which thickness will be appropriate to create a flush transition for the cement sheet. Once I've established I need to use a 3mm packer, I tape them onto the flange of the door at approximately 300mm intervals all the way around the frame. I do one last double check with my set square to make sure the timber is set at the appropriate thickness, then fix it in place with countersunk screws.
No mistake ever kept me late. We spent summers catching fireflies and winters on our skates. One big smile across my face. We used to dance our way to church on Sundays. Mama set the pace. Daydreamer, kidnap me. Take me back, all the way back to them days, running around in a gown and a crown, barefoot.
This frame extension is made out of primed treated timber and will create a backing for the battens we'll be adding later after we complete the cement sheet installation. After measuring and cutting the material, we're ready to install our first piece of cement sheet on this side of the studio. I'm preparing the battens in the standard way by adding a thin bead of liquid nails to all the contact points. The temporary bench helps take the weight of the cement sheet so we can accurately place it on the glue bead. I add a couple of nails to hold the sheet in place and then start preparing the edge that butts up against the door. After pre-drilling all the holes, I add 10 gauge stainless steel countersunk decking screws. One of the good reasons for using screws along the door frame edge is it avoids having to use a hammer so close to the aluminium frame and glass door. Because of the raked roof pattern on this wall, it's critical to dry fit each sheet before we glue it in place. By using packers between the bench and the bottom of the sheet, I can make small adjustments to get it in exactly the right position.
Daydreamer, kidnap me. Take me back, all the way back to them days. Daydreamer, kidnap me. Have me running around in a gown and a crown, barefoot. Have me running around, dressed in a gown, barefoot.
Staging for your construction process is important for a number of reasons. It enables us to install the product without damaging the material or injuring ourselves. In this case, I create a temporary timber bench that supports the weight of the cement sheet whilst we secure it in place. Once the support stumps are set to the correct height, I bring in a 6-metre piece of framing material. This was one of the roof rafters of our temporary shed we deconstructed earlier. I set it hard up against the wall and secure it to our stumps with screws. I'm setting the height of our temporary bench about 10 mil lower than the cement sheet will need to be in the final installation. The final step in this staging process is to secure 10 mil packers all along the timber bench and make sure they're level.
Hey, darling, can I tell you what's been on my mind? Sick and tired of the 9 to 5 in the city life. Hey, darling, we could get out of town, see the beautiful world around, wanna see it now.
The final step in preparation for installing the cement sheet is to add the packers on the window buff all around the window frame. This will allow water and moisture to drain out of the window system. The large window on this side of the studio has no eave to protect it from the rain, so it's extra critical we have an effective drainage system to help the window avoid developing dry rot over the life of the building.
Could you listen to somebody else? Will you only drink from the thoughts of yourself? Are you under the canopy spell? You dig in your heels and spread the disease. You're spreading the disease. Back up the drive a bit. Could you see what this is? This is a part of it all. Over and over, injustice to injury. This is a part of it all. Could you hike back to it, fight with it, sit with it? This is a part of it all. Ask around, be aware, make peace with what is there.
This concludes the installation of the cement sheeting for the exterior walls. To complete the weatherproofing of the windows, I'm adding a hardwood frame around the entire perimeter. The pre-painted hardwood timber framing creates an overlap between the cement sheet and the aluminium window frame. With this first window complete, I start preparing the identical window next to it. I'm adding pencil marks to the wall that'll be used as a guide to measure the pieces of framing we'll be adding. By pushing an offcut of the same framing material hard up against the aluminium frame, I can scribe an accurate pattern on the cement sheet of where the frame will sit on the wall. Using the pencil marks, I can now take a measurement for the first piece of framing that'll be at the top of our window. I cut this top piece about 20mm longer than the pencil marks. Later in the process, we'll be trimming off the excess. I temporarily install the piece using my rubber hammer to make sure it's sitting hard up against the aluminium window frame. I now cut the side pieces of the window 20mm longer than the pencil marks. I'm using screws to hold them in place, as it'll be easier to remove them later for the final trim of the frame.
Standing underneath the lights, look into each other's eyes. Tired snowflakes are coming down, collapse into water when they hit the ground.
I now fit the last piece of framing on the bottom, scribing it hard up against the two side pieces for an accurate fit. Once the bottom piece of framing is secured in its final position, I can accurately scribe the cut points of the rest of the frame pieces, starting with the top piece and then moving to the side pieces.
Hold my hand and hear the words I say. Close your eyes and let us fade away. A secret place for you and me. Let our minds be caught up in a dream. Quiet voices in the night. Time is running out of sight.
Once the framing pieces are returned to their original position and secured with the screws, I add galvanized nails approximately every 300mm.
Hold my hand and hear the words I say. Close your eyes and let us fade away. Build a secret place for you and me. Let our minds be caught up in a dream.
With the window frames complete on this wall, I can start the process of adding the battens over the seams of the cement sheet. I'm using a purpose-made batten material that's 44mm wide, 11mm thick, and comes pre-primed. For the small lengths of batten around the window frame, I'm adding a bead of glue and then securing them with a galvanized nail.
Yesterday, there was sun and there was rain. Beauty in the mundane. And as the light startled our eyes, we let go of disguise.
To install the battens that run the full height of our wall, I rough cut them about 20mm longer than they'll be. I can then temporarily fit them in position to scribe a mark, leaving a gap for the batten that'll run across the top of the wall. I then secure the batten with a single galvanized nail near the top of the wall. This enables me to double check that the nails I'll be securing the batten with don't run into any existing nails or screws that are in the wall. After attaching all the vertical battens with galvanized nails, I'm ready to install the last piece that runs across the top of the wall.
And now, there's something in the air, and a sparkly shimmer on our skin, restoring everything within.
My client is painting the walls black as I install all the battens around the entire studio. We've been weatherproof for a couple of weeks now, so the inside is dry enough for us to start installing the plywood wall sheeting. I'm cutting the plywood outside the studio to avoid adding any unnecessary sawdust to the interior. Here I'm using a scrap piece of plywood to help protect our wall paneling as I make the cut.
And I can reach you from a distance. I can, so beautiful. I can hear you within the silence.
The local hardware store only had 3 sheets of this particular plywood, so we'll continue the installation after we're resupplied. In the meantime, we'll move on to adding more battens to the outside of the wall. Here I'm custom cutting small pieces of batten to fit round the beam that holds up the outside awning area. After scribing and trimming the piece, I double check its fit before adding glue and nailing it in place.
Stay close when it rains. Let me keep parts of you. Hand in hand is how we sleep every night. And I will watch you, breath after breath, hold on, so beautiful.
Before adding battens to this wall of the studio, I'm installing the hardwood exterior window framing. I'm using the same method to fix the timber frames in place as I did on the previous window. First adding countersunk screws, then finishing it off with galvanized nails. All the hardwood has been pre-painted with a primer and 2 top coats. This will ensure it doesn't warp or cup when exposed to the elements.
Every step, every breath. For you, my head's up over the clouds. For you, if there's a valley, I'd build a bridge so that you could get by. Or I'd grow wings so we could fly. Daydreaming is my new middle name. This is not a game for me. Imagining is my new best friend. And raise all I see.
With the frames complete on the door and window, I can now start adding the battens to this side of the studio. The battens we're adding have 2 purposes. The principal purpose is to add a seam between the 2 pieces of cement sheet to help protect it from the weather, and then adding false battens to help keep the pattern symmetrical for looks.
Peel off the layer and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memory.
To complete the installation of the battens, I'm caulking the edges where they meet the cement sheet. I'm using a purpose-made exterior caulking product that I apply with my caulking gun. After injecting the caulking in the corner of the batten and the cement sheet, I wipe it down with a wet rag to leave a smooth finish.
Peel off the layer and breathe. Lift up your head and lead. Count the stars up before you leave.
My client continues the process of painting the exterior walls in black while I complete the installation of the framing of the doorway under the open eave area. One of the reasons I pre-drill all my holes before adding the nails is to make sure there's no hidden fixings underneath.
Give me tears so I can cry. And give me heart so I don't die. Give me tears so I can cry. And give me heart so I don't die.
With most of the battens installed on the walls, my client wanted to add a decorative grid pattern of battens to help give the studio a more Japanese architectural style. With my client pleased with the grid pattern on this wall, we repeated the same pattern on the front of the art studio. The final pieces of cement sheet we need to install for our exterior wall cladding are on the low side of the studio where there's no eave over the outside awning area. I'm using a combination of construction adhesive and galvanized nails to hold these pieces of cement sheet in place.
Trade your money for rest. Learn to master your mind. Mud on your boots tell the story of where you've been. Travel, beat up, warning with settled soul. Trust your gut, you have earned at least that.
I now install the last of our battens on the awning overhang. It's important to have a solid connection with the battens on the cement sheet, as I'll be installing brackets to hold the guttering up over the top of these battens later.
You said, let me tell you everything I've seen, the friends I've made, and then you tell me how you've been. Look a little closer, it's been quite some time, but you gotta let me know if I'm out of line. But there's some words that I just wanna hear you say, to put it all straight before this night turns into day, and then I'm on my way. Yeah. Yes, I'm on my way.
With all the exterior wall cladding complete, we're going to move our attention back inside. I've been resupplied with some of the plywood paneling we're using for the inside walls, so I'm going to continue to install it around the windows. We're using a marine ply similar to what we installed on the ceiling, except these sheets are 8mm thick instead of 6mm. I'm securing the plywood with 30mm long finishing nails, which will be covered by hardwood battens later.
9 to 5 was my dad's advice. Don't think twice, I want the luxury life. My beauty can lose it, I'll use it. I'll take what I want. Oh yeah. A whole lot of ticket, not enough time. A whole lot of work for a trophy wife.
To make the covered awning area more substantial, my client wanted to add a hardwood batten privacy screen. The first step is to build a frame the battens will be secured to. After getting some accurate measurements of the opening size, I start to prepare the treated pine 30 by 60 framing material.
Spending your Sunday at the gym, trying to fit in. Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this.
After checking the vertical piece of framing is the right length, I duplicate it and start the process of adding notches for the horizontal pieces that'll connect into it.
A whole lot of sweat for a trophy wife, for this trophy life. The clock keeps ticking, still running out of time.
By using the depth gauge on my saw, I can efficiently cut 10mm deep notches in the vertical pieces. This will help keep the horizontal pieces connected and secure over time.
Your eyelids and perfect lips got me rushing pen and I'm so lit. Like lilies you open, the fragrance goes to my head, my darling. I get everything that has been, don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it.
To add extra strength where the frame connects together, I'm using waterproof glue in conjunction with screws and nails. After dry assembling the corner with the galvanized screws, I pull it apart to add the glue and then reassemble it.
Now everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it. Everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more.
plumb, I glue and screw it to the wall and post.
Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true. No matter where I go, I'm coming home to you. Been walking down the street so many times, my feet know every brick and stone. Could wear a blindfold. No matter what I do, I'm coming home to you.
Once it's secured in place with galvanized screws, I add additional galvanized nails for extra strength.
I have seen many places where the beauty never ends.
After checking the horizontal pieces fit correctly, I install them using galvanized nails and waterproof glue, pre-drilling the holes to avoid splitting the timber.
Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true. No matter where I go, I'm coming home to you. Been walking down the street so many times, my feet know every brick and stone. Could wear a blindfold. No matter what I do, I'm coming home to you.
Before installing the oiled hardwood battens to the frame we just constructed, I completed all the black painting for this side of the studio. I want to pre-drill all the battens for easy installation with decking screws to the frame we constructed. By cutting one of the battens to the correct length and temporarily clamping it to the frame, I can create pencil marks to where the screw holes will need to be. I double check both ends of the frame to make sure they're going to be in alignment. I've custom cut a template that fits the frame exactly. This template has pencil marks that'll set the spacing for the battens to help keep them even and symmetrical when we install them later. I then construct a jig on my sawhorses. This way all the screw holes in the battens can come out exactly the same. I transfer the pencil marks from the first batten we aligned with our frame, and then assemble the jig with some screws and add a stopper on one end. This will work as a reference point to push the batten hard up against and have all the screw holes come out exactly the same. With the jig assembled and solid, I clamp the first batten in place and start the process of pre-drilling the 4 holes we'll need to assemble the battens onto our frame.
You master how to survive. You turn rain into a blue sky. Oh, when the wind blows and the windows are closing.
With our 4 holes pre-drilled with a specialised countersink drill bit, I can install the first batten and double check that our jig and templates are working correctly. I've taped a 10mm packer on the top of the batten. This will serve as a spacer and allows me to push the batten hard up against the top of the frame, allowing an accurate reference point for when we fix the screws in.
There's no use in looking back, going back, wishing back.
With the first deck screw securing the batten in place, I install the other 3 screws using my clamp to hold it in the right position. I then repeat the process for the remaining battens until I reach the end of the frame.
Can I go to sleep, buried in my chair? The only thing that's left. If you have love, you wanna give me some, and I will wait for
and guttering, complete the painting of the exterior walls with black paint, and finish all the elements on the inside of our studio, like wall paneling, window framing, and finally complete the pet door. I don't have a lot of expertise when it comes to installing guttering, but there's a few key elements you have to keep in mind. Having enough brackets to distribute the weight of the gutter when it's full of water, and aligning the brackets so it creates a very gradual slope, helping the water float to one edge of the guttering where it can drain out onto the ground. I achieve this gradual slope by setting each bracket a couple of millimeters lower than the previous bracket. This will create a 10 millimeter drop from one edge of the guttering to the edge where the water will drain out. I'm using 3 flathead galvanized screws to secure the brackets. They're 50 mil long, so they're deep enough to penetrate through the batten and into the material behind it.
Hold my hand and hear the words I say. Close your eyes and let us fade away. Build a secret place for you and me. Let our minds be caught up in a dream.
With all the brackets securely installed on every second batten, I installed the guttering. It came in one piece and didn't need any joins. The final part of the process was installing a rain chain instead of a downpipe. A rain chain is an alternative method of directing the water that's caught on the roof into the gutter and then down onto the ground. The next step in completing our roof is to add tin flashing to all the edges.
The walls are listening when we talk, making echoes as we walk. There's no one left but you and me.
The first step in the process of installing our corner flashing on the roof is to get really accurate measurements, as I don't have any spare material. It's easier and safer to make the cut on the ground, so after transferring the measurement to the tin, I use my grinder to make the cut.
Castles out of sand, reaching for the grand. As willows align, we lose track of time. Head up high, now we climb. Oh, dreamy, breezy, we go. Easy, easy on our tiptoes, undercover agents of the other, beyond gravel, beyond dawn.
After placing all the corner material in its correct position and temporarily securing it with duct tape, I prepare to screw the corner material into the corrugated iron. I'm using some scrap marine ply to help avoid buckling the corrugated iron as I install the corner material. I'm pre-drilling all my holes and then securing the tin with a hex head roofing screw that goes through the corner tin, through the roof and into the wood frame below.
I wouldn't want it any other way. Dreamy, breezy, we go. Easy, easy on our tiptoes, undercover agents of the other, beyond gravel, beyond dawn.
I'm now changing my focus to finishing off the interior of the art studio. I'm using pre-painted 6mm plywood to panel the inside of this wall. This first sheet sits over a power outlet, so I'll mark out a hole for the power point that'll be installed later. To create an accurate cutout for the power point, I'm placing the panel in the position it'll be when it's installed, then use my set squares to calculate the square cutout I'll be doing with my jigsaw.
And I can reach you from a distance. I can, so beautiful. I can hear you within the silence. Ooh, we will dance away.
effective way of cutting a square in a panel like this is to drill 4 holes in each corner with a 10mm drill bit, then insert the jigsaw and do the cutout. Correct position, I fix it in place with 30mm finishing nails.
We are silver line, one of a kind, you and me. We will dance away lonely days right here.
After installing the rest of the panels on this wall, I'm going to complete the final step in the window installation. This involves injecting expansion foam in between the gap between the wall and the window frame. It's a purpose-made product made for creating a water and airtight seal in a gap like this. After shaking the can for the appropriate time, I inject the foam into the gap between the window and our wall. When we installed the window, we left a 10mm gap between the wall and the window specifically for this product to be injected into. With this window complete, I move on to the other windows and doors. You'll notice I've got a drop sheet laid out underneath the window. This is to catch any of the foam that spills, as it's extremely sticky and hard to remove.
Tonight we'll turn minutes into days, and nothing's gonna make me look away. Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you leave.
After giving the expansion foam 24 hours to cure, we cut the excess off with a paint scraper and Stanley knife.
Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memory.
Once I've cut the bulk of the foam off, I finish it off with some sandpaper to make sure none of the foam is sitting proud of the gap and will get in the way of the trim we'll be installing later.
Peel off a layer and breathe. Lift up your head and lead. Count the stars up before you leave. Save a kiss, pretty please. Try to reminisce over me. Know that I will cherish your memory.
The next step in completing the windows is to add a small strip of timber to extend the reveal on the inside of the windows so it matches the wall plane. My client purchased second-hand windows to save money, and they came with existing reveals that didn't match the thickness of our walls. So by adding a small timber extension, we can match the wall plane on the inside of our studio walls.
Daydreaming is my new middle name. This is not a game for me. Imagine is my new best friend, and raise all I see. I got a PhD in love. My heart covers every degree. There's no guarantee in love. No, we just have to wait and see.
The doors we installed came from a different manufacturer than the windows and didn't include inside framing, which is sometimes called reveals. I'm framing out the inside of these doors with two different dimensions of timber. The first piece I'm adding is to cover the gap we just filled with the expansion foam. After test fitting the piece, I pre-drill nail holes on the ground and then install it on the frame. Piece I'm adding to the interior door frame is a larger piece. It's wide enough to cover the thickness of the wall and match the inside plane of the plywood panelling. The final step in completing the doors and windows is to add the frame that overlaps the wall panels. To make the installation more efficient, I've pre-painted all the pieces I'll be needing. I start this process by adding the bottom piece first. I use an offcut to make sure the bottom piece is sitting symmetrical before I nail it in place.
Mud on your boots tell the story of where you've been. Travel, beat up, born in with settled soul. Trust your gut, you have earned at least that. Age has proven to be kind. Age has proven to be kind.
One of the last elements necessary to complete the walls that are painted black is to add the skirting board. To achieve an accurate fit, I've cut the piece of skirting board slightly oversized, then put it in its final position and scribe a mark where I can trim it into the exact size.
Spending your Sunday at the gym, trying to fit in. Counting the days until I meet my future husband. I try to be kind to myself. I said, girl, you got this. A whole lot of ticking, not enough time, not enough time.
With the two black walls nearly complete, the last step is to add 50mm battens, similar to what we did to the outside walls. I'm using a small offcut to help me scribe this first corner piece. After cutting the batten on my saw, I return it and check it for fit with the offcut, then nail it in place.
It's a whole lot of ticking, not enough time, not enough time. A whole lot of work, struggle for your life, oh my. A whole lot of thinking, behind these eyes, behind these eyes,
The final wall in our studio is going to be sheeted in a hardwood marine ply, left in its natural finish. After cutting the sheets to size, I nail them in place with 30mm finishing nails. Most of the nails will be covered by battens, but any that aren't are almost invisible.
Of all the magic places in the world I've been to, this is where my heart is. Oh, you know it's true. No matter where I go, I'm coming home to you. Been walking down the street so many times, my feet know every brick and stone. Could wear a blindfold. No matter what I do, I'm coming home to you.
With all the wall paneling complete, I add the skirting boards. I'm using 140 by 20mm pine planking. We pre-painted it black like I've done with many of the materials throughout this project. I'm using 60mm finishing nails. Here you can see me measuring out where the stud would be, then pre-drilling the hole. After the nails are secure, I countersink them with my nail punch.
Gonna stay in this moment. Gonna lay here on the grass. I don't need to feel lonely. I am finally home at last.
To finish the wall off, I'm adding hardwood battens where the plywood seams meet each other. I start by adding battens in the corners, the ceiling, and then fill out the middle.
Cutting grass and chopping wood can be romantic. Sipping coffee under the apple tree is gentlemanly. Well, you're a good man, quite the best man, a real fine man. When the wind blows and the windows are closing, you let the world know that what has been has been. And there's no use in going back, wishing back.
The final step in the construction of our art studio is to complete the pet door. My client has a cat. She wanted it to be able to come and go at will, so we installed a commercial pet door and custom built the frame around it. I'm assembling all the pre-painted framing elements, then holding them together with masking tape before pre-drilling and nailing them to the wall.
Come closer, dance for me. Easy, tiger, easy, let your hair down. Come closer, let me see all your million faces and all your million mistakes. You don't need to hide. Come closer so that we can be together. Everything that has been don't matter no more. We've burned it. All those whirlwinds can't touch us no more. We've earned it.
With all the construction complete on the art studio, I'm dismantling the saw bench.
Your eyelids and perfect lips